All right. Hello, everyone. Can you hear me okay? Well, nice to see everyone from all over the world. If you haven't already, please feel free to say hi and what country you're from in the chat, perhaps even a little bit about yourself. My name is David Malan, and this is the last of CS50's series of New Year's seminars. We began with Python a few weeks back, then moved on to SQL, then Linux, and now we'll focus on game development. You might find, if you attended any of these other seminars, that this seminar is a little more comfortable, if you will, whereby you'll need some client-side software on your Mac or PC per my email yesterday. Not to worry if you don't have the requisite software already installed, and not to worry if you run into any trouble today with getting the software installed. Indeed, if tonight goes a little too fast or you get a little lost, no worries. All of the seminar's materials and the video and the code will be posted on the course's website thereafter. So you're welcome to work through things again at your own pace. Before we begin, let me let you know that we have this amazing team of mentors, some of whom will be with us here tonight. If you have any questions during the seminar, please do feel free to ask via the chat as well as via Ed, the course's Q&A platform. And we also have a tradition, as you may know, of beginning with a quick group photo. If you would like to participate in this tradition, go ahead now and turn on your cameras if you would like to opt in. And in just a moment, we need everyone to look as sharp as they can with a big smile, and in a moment, perhaps a wave if you'd like. And one of our colleagues behind the scenes is going to start taking a whole bunch of screenshots so that we can fit all 60 plus of us into one big group photo. And we'll post this on the course's website tomorrow after we've stitched everything together into one big mosaic. All right, thanks to Shin behind the scenes. So I'm so pleased to welcome back to CS50's team, Colton Ogden, whom you might know from CS50's introduction to game development. And in fact, if you're here for the very first time to CS50 for just a taste of game development, know that after this seminar, if you like what you see and you enjoy diving into the world of games, there's a whole free course you can take via OpenCourseWare or via edX. And we'll post in just a moment those links into the chat window. Without further ado, allow me to introduce that course's and this seminar's instructor, CS50's own Colton Ogden.
Awesome. Thanks so much, David. Super nice to be here. Thanks everyone for attending. As David said, this is indeed a little bit more on the technical side if you've been doing some of the other seminars, but we're going to do our best to sort of keep things well paced and more conceptual so that everyone can follow along. I'm going to start with making sure that I'm sharing my screen here so you guys can see my slide deck. Let's just make sure that's getting shared. So now you can see that, hopefully. And I'm also going to pull up the chat just so I can keep tabs on that as well. So as David said, this is a introduction sort of to game development. This is a taste of game development, so to speak, which is the seminar's title. This is pre-CS50 Games Edition. And to illustrate this, and to really sort of help us get into the world of game development, I figured we would use Pong as an illustration of that. Shown here is a Pong console from the 70s, many of which of this variety were produced. I'm going to go ahead and make sure that I can use my slide deck here. Our goal in this seminar is to, from scratch, using a couple of tools, primarily the language Lua and the 2D game development framework Love 2D, we'll be able to create this game here, or something very similar to this, a version of Pong, which sort of harkens back to the version from the 70s, the original arcade version, but with a couple of our own obvious twists on it. For example, the ability to press enter, which keyboards in their current incarnation certainly didn't exist back then. David and others are going to be posting links in the chat to talk about how to get everything set up on your machine. So if you're on a Windows machine or a Mac, you'll be able to get set up. In addition, you can also get set up on Linux, although it's a little bit more work to do so. And to that end, I will show you the technologies that we're going to use and also maybe point us in the direction of those websites where you can get a little bit more information on how to install stuff. So as I just said, we're going to be using two things primarily in this seminar, which are Lua, the programming language, which is kind of similar to Python or JavaScript if you've seen either of those in the past, and Love2D, which is shown by the icon here on the right side of the screen, which is it's called a 2D game development framework, which is sort of a set of tools, or kind of like a box of Legos, or a box of boxes of Legos rather, that let us do various things like tie into graphics functions, tie into input, tie into sound, all sorts of different things. I'm going to go ahead and hit exit here just so you can see a couple of important links that I want to show. Here are the links, by the way. So let me just make this large again, and then maybe post these in the, whoops, I did not mean to do that. Let me go ahead and make sure that I am in here. I'm just going to, in case these aren't being posted in the chat, or at least not explicitly, I'm going to copy a couple of important links for you to take a look at. So love2d.org, obviously the website that the framework is being hosted on, and then the wiki page to show sort of how to get started. So here's what the love2d.org homepage looks like. You can see where the download options are available here towards the top. It might be a little bit small if you're looking at my screen from your end, but there's options for Windows, options for Mac, options for Linux, and then even some options for things like Android and iOS. So there's a lot of support for Love2D. We officially have instructions for getting it set up on Windows and Mac. And specifically, we also have instructions for getting it set up for those operating systems using a text editor / IDE called Visual Studio Code. I apologize if this is a lot. When David was talking about how there were sort of a technical, I guess, set of steps before we can actually get started. That's sort of what we are referring to. There are a lot of pieces to get started with this, but once we're up and running, it'll be very smooth and easy, I promise. So we officially recommend Visual Studio Code to write software with this. But you can write games using Love2D with any text editor. You could technically use Notepad, you could use Atom, you could use any number of IDEs and text editors. But we specifically recommend Visual Studio Code for reasons that we will talk about very shortly. I'm going to make sure I also follow the chat. So if you have any questions throughout this seminar, do ask in the chat, and either some mentors or I will try to answer as best as possible. And I'll be keeping a look on that periodically. And then, for example, Victor saying that the Mac doesn't install Lua, just a balloon bouncing, and that is it. That just means that you're not loading a game project. So it's actually loading the Love2D framework, but not a game per se, a folder with a particular file in it. We'll talk about the specifics of that going forward here. Let me go back to my slide deck. So those are the two important links as to Love2D, where to download it. The wiki page for how to get started, for example, is up here. So if I go, I'm going to navigate through to the wiki sort of indirectly here. Or rather, I'll just use the link that I posted. So this page is important because there's a lot of steps here for how to get it set up on your operating system. If, for example, you're doing something, you're running an operating system that's not Windows or Mac, and you want more specific setup instructions, even for those operating systems, for example, CLI support, there's a lot of handy steps here. So do check that out if you would wish. Additionally, a really important thing to look at is the manual or reference for the language we'll be using. So that's the framework we're going to be using. It's sort of a set of functions or tools that are pre-built for us. But additionally, we're going to be programming in a programming language, and that programming language is Lua. So if I go ahead and type that into the chat there, if you want a reference on the specifics of the Lua programming language, syntax and whatnot, this is an often referenced website, the Lua 5.3 reference manual. You can find a lot of information in here, a lot of which you won't necessarily need in order to be productive in Lua, but certainly a lot of interesting bits of information and specifics if you're ever unsure. I'm going to go back in presentation mode here and go on to the next slide, and then look at the chat before we continue on with some of the more interesting, less technical content, I should say. Yeah, Victor is saying Lua is not installed on Mac. Do make sure, Victor, that the path that you're referencing in that field with that extension, if you have installed the extension listed in the instructions, is pointed to the location where your Love.exe is located, and also is referencing that you're in a project with a main.lua file. You will need a main.lua file. If all else fails, for some reason, if your system's not cooperating with the setup, you can click and drag a folder with the main.lua inside of it to the executable's location to the program. If it's on your dock, for example, you drag the folder onto the love.app on the dock, and that's a temporary workaround. I'm not entirely sure why it may otherwise not be working on your system, but in the meantime, if you want to maybe post in the ed discussion group a little bit more about your system and your setup and the steps that you've tried, you might be able to get assistance to that end as well. Okay. Yeah, if folks are having trouble with the extension, then so just for reference, in the instructions, we will talk about this, or we meant to talk about this in a little bit, but the short, I guess, or cutting to the chase, the reason that we recommend VS Code is because you can install an extension to run Love2D programs directly from VS Code rather than having to click and drag a folder onto an executable or run a command at the CLI to do so. So if you go to your extension bar on the left, which is Control-Shift-X on Windows and Command-Shift-X on Mac, you can type in Pixelbyte Studios. There's a Love2D support add-on or extension. And then this, if you use the installer on Windows, this will just work out of the gate. And on Mac, you have to do an additional step, which is to go into the settings and then type in the location of your love.app and then contents, Mac OS, or resources. I forget the exact path. It's in the instructions that we've linked. But basically, type that into the, basically here in the extension settings, this Love2D path field. If you do that correctly on Mac and then you do it by default on Windows, you can just run Love2D programs in VS Code with a shortcut. It's by default Alt-L on Windows and Command-L on Macs. So do try and get that set up. If you're having issues getting that to work, you can, in the meantime, on Mac, as I said, put a reference to the program, drag the program into your dock, and then click and drag folder onto that program, and do the equivalent on Windows using a shortcut on your desktop or your taskbar or the like. And it's cruder, it's less fluid, but it's something to get you by until you have maybe figured why the shortcut's not working. As I said, do post. If you're having issues in the chat here, maybe there's a mentor available to assist. And if not, do post in the ed discussion groups, because everyone's systems may be a little bit different. Your setup may differ from somebody else's. So it's going to be difficult to troubleshoot all of that in real time. But in the meantime, you certainly can manually click and drag your project folder onto the executable to get started. Jonathan asks, is there an advantage to making games in code like Lua and Love2D instead of a more GUI-based game engine like Unity or Game Maker? I would probably not put, well, I guess I would probably put Game Maker and Unity in the same domain. Unity, I would say, is a lot lower level, and Game Maker is a bit higher level, but they still kind of are. You can script in Game Maker, so technically they are kind of in the same field. But I would say there aren't necessarily advantages. There's pedagogical advantages in understanding how things work by starting in a code-based environment and then maybe transitioning to a GUI-based environment. For folks that are trying to get into game development professionally, I'd probably recommend using something like Unity or Unreal Engine if you're on the more higher end of graphics and performance. Although Unity is good in those regards now as well. But certainly to get started and to understand game development at a basic level, I would probably recommend learning things in code a bit more. Sorry, Victor, that things are not working with your setup. Do post an ad or maybe more details here in the chat if there's a mentor available. But I'm not sure we'll have time to in-depth troubleshoot the Pixelbyte Studios plugin. But for now, do just drag. If all else fails, do drag the folder onto the executable. Unity is a program. Unity is a GUI-based, it's an IDE for games, essentially, more or less. It does tie into external text editors, which an IDE typically, it would at least embed it normally, and Unity doesn't. It kind of offloads it to another editor. But for all other intents and purposes, it's sort of like an IDE for game development, and super feature-rich. I highly recommend people check it out if they're unfamiliar. But forging ahead, so that was kind of more of the technical setup information. Getting into the more juicy aspects of the seminar, I kind of wanted to illustrate for those especially less comfortable with game development what a game is in the abstract, and then we can maybe dive a little bit more into some more detail. But a game, at least in my mind, as I've more recently come to think of it, is kind of like a flip book, right? In the sense that a flip book is basically a set of images in a little booklet, kind of like a notepad or a sticky notepad that somebody's drawn a bunch of pictures on, and they all are slightly different, such that when you flip through all of them fast, you have this animation that you can see that loops through. And this is how just 2D animation generally works. But the difference with games is that a game is kind of like a flip book that you're writing as you're flipping through the pages. You're sort of changing things and making decisions and altering the way things are drawn in real time, but you're kind of still doing the same thing. It's a dynamic animation, really, at the core of it. And additionally, there are a few core pieces of that belong to a game, specifically beyond this idea of a flip book that we're going to talk about a little bit. But I think the first thing that I want to do before we maybe talk about this, which just to tease, is a game loop. This is really a basic illustration of a game loop, which we'll talk about. I want to go over back to the code, the text editor, and kind of start explaining how to get even started writing code in Love2D. So there's a GitHub repo that has the code thus far. I'm going to just go ahead and paste it in the chat. So this has the code from both the prior to the first iteration of this seminar and the first iteration of the seminar, which already took place. So you can see what the final code will look like, but this will also be what I end up posting to as we write the code together today. And if you don't want to get spoiled at all and see what the code looks like, don't look through it. But if you are stuck at some point and you want to look ahead or maybe fill in some blanks or experiment with it even on the side while we're doing this, do feel free to clone that repository to download the code. But I'll be contributing what we write today to that repo, so you can go ahead and check that out as we go along. After Love and Love2D support, Parminder, you're going to want to follow the instructions for Ubuntu on the Love2D wiki, which offhand I'm not entirely familiar with. Generally, for CLI-based environments, you'll just be typing the location to the Love executable on Linux, and then you'll do space, and then the location of the folder in which you have your code. And to show exactly what I mean by the folder with your code, let's assume that I have on my desktop some folder called, in this case, it's called Pong Seminar. It's just in a directory on my machine, and I have it loaded up here in VS Code. You can load a folder into VS Code by clicking and dragging it into VS Code if you've just installed it. And I've created a subdirectory in here called Live2, just because this is the version 2 of this seminar, the second iteration of it. I'm going to create a new file, and within that Live2 directory, I'm going to call it main.lua. This is really important. It has to be called main.lua, because this is where Love2D will essentially look to see where is the program, the game, starting from. There's a starting point that it has to look for in order to load your game correctly. And if it doesn't find that file, it'll just load the balloon that some folks look like they have already seen. So what I'm going to do here in main.lua is I'm just going to write something up really quick. This is just a test to make sure that things are working. I'm going to say function love.draw, and then I'm going to say love.graphics.print hello world, just like that. And then I'm going to use the pixel byte shortcut, which is Alt-L on Windows if it's been installed. And if this hasn't been installed on your machine or it's not working, you can now click and drag that folder with the main.lua onto the executable. And once I do this, you can see that a window does pop up on my screen. And in really small text, you can see at the top left corner, hello world in white text with a black background. So that proves to me that I have everything working and running. It's able to find the main.lua, and it's able to print that hello world onto the screen. Now, somebody's saying that the video is very delayed. Hopefully it's not super lagging or delayed for everybody, but if more folks want to chime in and just maybe comment on whether that's the case, hopefully it's not. But that is how we get to actually running our games. We got VS Code. We've optionally got that plugin installed. We have Love2D installed on our machine. So now we can actually use Love2D to load our game project. All right, Elena and Alan, Kuyan, everyone's saying it looks good. Okay, Kyle, I would maybe check to see if your internet connection's okay right now. It sounds like everyone else is not having any bandwidth issues per se. But sorry to hear that that's the case. I do sympathize. So that's how you load a Love2D project. So it has to be in a folder. It has to have, there has to be a main.lua, and that main.lua is what effectively will get jump started or run or executed in order to start the game running. So I'm going to go back to my slide deck here and then continue on to the next slide. Hopefully people are able to run that. Just maybe I'll leave it on there for just another second so that people can see it. If you, this is included in the instructions for the Windows and Mac setup, by the way. So if you've gotten that to work, you've already seen and done this, but just in case you haven't, here's the code. So Gene, it sounds like you're, you may not have Love installed in the correct location. I'm not sure if maybe you downloaded the zip instead of the Windows installer. If you're on Windows or if you're on Mac, it may not be in your applications folder. Do follow the instructions. If not, click and drag the folder onto the Love executable if all else fails, and that should work. Just to make sure folks are okay and not having too many technical difficulties here. Okay, I'm gonna go ahead and forge ahead now. So we'll go back to the slide deck. Now, I want to talk about a really important concept in games. So we talked about essentially what a game is in the very abstract, right? A sort of flip book that we are in control of in real time, right? An infinitely scrolling flip book, right? A flip book with infinite pages. And thanks to Justin in the chat there for posting the seminar instructions. Do appreciate that. Going back to the idea of what a game is in a slightly more technical sense, a game is an infinite loop. And in computer science and programming, if you've taken CS50, for example, you might have seen examples of where infinite loops are bad. And often they are bad. They're often the result of bugs, right? You have a while loop or some loop that's not ever returning false. If you're familiar with loops, typically a loop keeps executing as long as some condition is true. But if that condition never becomes false, that loop will just run forever and ever and ever. There are some instances in which infinite loops are actually a good thing. For example, servers that exist online that are always listening for connections on the internet for clients, those want to have an infinite loop running to be able to serve content back to the users. They want to always be on and active and working. Games are another example of infinite loops that want to be always running. A game is a set of, basically at its core, 3 instructions running in a cycle, in a series. You have input processing shown here on the left. You have an update function here in the middle, which's purpose is to essentially update all the things on the screen, whether they're monsters or items or what have you. And this might take place, as shown by this illustration, more than one time every frame. And to be clear, this loop takes place typically once every frame, sometimes more, sometimes less. Following the update set of that game loop, you then have a render sort of function or set of functionality, which purpose is to take the information from the update and then draw it onto the screen such that we can visually parse the changes that have taken place in our game world or our game state. And then as you can see here after render, it goes all the way back to processing input again. And once that happens, it just repeats ad infinitum. And this input processing thing is important too. Input processing so that we can move around on the screen, we can change the behavior of the game. Games without input processing wouldn't really be games. It would be much more akin to simulations or animations. So the processing of the input is an extremely important step. So these 3 core things, in a simplified sense, run infinitely, and this is how we can get a game to work. And analogs for this exist in Love2D, and very simply so. So love.draw is something that we've already seen. It's in a very important function. Love.draw is the analog to the render box in that illustration. And love.draw is a function, so basically a set of functionality that can get executed at will at some other time, some other point in time. Function love.draw is something that Love2D expects to exist. So we didn't just make up love.draw. We are specifically calling it love.draw because Love2D is going to read this file and it's going to look for that function and it's going to essentially plug it in to a game loop that it manages for us. So rather than us having to write an infinite loop and manage the logic behind that, there's an infinite loop running with Love2D that takes our building blocks, our love.draw, our, as I'm going to write here, function love.update, which is the analog to the update part of that chunk. And then also love.keyPressed, which takes in a key, which is the input processing side of that diagram. And input processing also does take place, as we'll see in the love.update function as well. And these three, in a simplified sense, are the core elements of the game loop. We include these in our project, and then we can start basically creating games. And most of the pieces that are necessary for that. These aren't the only functions that are important or requisite in all cases. For example, there's a function called love.load, which is really important, that only happens one time, which allows us to initiate a lot of the stuff in our code, and we can use that as well. But the other functions are the core to getting things to work. So to summarize, love2d is going to look at this main.lua file. It's going to look to see where is my input processing, where is my update, and where's my render, and then I'm going to plug those into a game loop, and it's going to just work essentially. So love.update is going to map to this update phase. This love.draw is going to map to this render phase, and then love.keyPressed in coordination with love.update, as we'll see later, is going to feed into this process input. And then this is just going to run for us automatically forever and ever. But to be clear, these need to be called love.load, love.update, love.keyPressed, and love.draw, these functions, these set of functions specifically. So I'm going to look in the chat now, and then just to make sure folks are doing okay here. So Jean says it's working now, which is great to hear. I'm very happy. Aaron says I'm lost. Ooh, Aaron, if you could maybe ask, and maybe a mentor I can assist with elucidating anything. Tushar asks, is Netflix an infinite loop? Well, yes, actually. Their servers are running on an infinite loop. The browser, the web browser that you're looking at everything on, is running in an infinite loop and drawing everything that Netflix is showing over and over and over again. Really, web applications and games at the end of the day are not super dissimilar. They are, web applications tend to be a bit more structured and set up for sort of textual and graphical content, and to be laid out in a more human readable way, like you're reading content, since that's essentially what its purpose is. But they are very similar mechanically at the end of the day. The main function, so in love2d, there is no main function, which might be confusing some people. The main function is this main.lua existing, right? So love2d is gonna say, where's my main.lua file? It's not looking for a function per se. It looks for a bunch of these functions and then puts them into the game loop for us, and then runs the game loop over and over again. Main.lua is the equivalent of having a main function in C or C++ or Java or what have you. But all of these predefined functions would kind of be an equivalent to how we need to define a main function in C. We need to define a love.load, love.update, love.keyPress, and love.draw function in love2d for it to work properly. And somebody asked, do they need to be called love.load and update and keyPressed and draw? Yes, they need to be called love.load, update, keyPressed, and draw. If we do not specify the love dot, it'll just be us creating a function called love that exists in the ether. Love2d will not know of its existence or where to put it or what to do with it. It'll just be a function that we own and know of only ourselves, if that makes sense. All right. And it is like a class, kind of. Everything in Lua specifically is a table, and love is a table with a set of function references that it will go through, and it'll iterate through. This is a bit of a technical detail, but in Lua there's only really one data structure that's beyond very simple data, which is called a table, and it's very similar to a hash map or an object or a dictionary coming from JavaScript, Python, etc. And in this case, love is a global table that has function references that we are essentially overriding by defining these functions. And then love knows about those and will plug them into or give its own default to the game loop that it internally is storing. But no need to worry about those technical details. That's only for people that are interested. The functions aren't predefined, but Lua looks for a function we define with a specific name. Yes, yeah, in a sense, love2d specifically is going to be looking for which is looking for those named functions in Lua. Yes, and it's specifically going to be going through this object somewhere called love that we haven't implemented, but Love2D has, and it has these keys, these values, or these keys that map to values, or map to functions rather. These tags, you could think of them, called load, update, key pressed, and draw, that we are effectively saying, I don't want you to use the built-in default versions of that. I want you to use my version of those functions, because I want my game code to be injected into Love2D, if that makes sense. That's effectively what this is doing. So, all right. I'm getting the sense that people are following along a little bit more easily now. It looks like people are getting their systems to work with the code and whatnot. So that's encouraging. I'm very happy to know that. I do apologize to people who are having some issues getting it to work on their system. Again, do post an ed if you want to keep carrying on using Lua and Love in the future after the seminar, so that you can get it working smoothly on your system. But I do apologize. Everyone's system, little quirks can cause big issues sometimes. So I do apologize to that. Rosa asks, what does DT stand for? Oh, that's a great question. So we haven't talked about DT. We haven't talked about key here. We will talk about all of those details. Those are very important details. But in the meantime, why don't we first get something that looks a little bit more similar to this, at least aesthetically. So currently we're having a problem where the game window is, first of all, the aspect ratio is weird. It's square, and the text is really tiny. But if we're looking at this screenshot, you see, for example, well, this text is really big. The title and the press enter and the scores, those are really big. So there's something that we need to address, and that is, if I can get this working without the zoom settings kind of getting in the way. So if folks can go to this URL, it looks pixelated, and that is going to be normal. So this is kind of an aesthetic decision, but since we're talking about Pong, we're talking about an old game, and GD50, especially if you're interested in game development and you decide to go into looking at GD50 and future game development, using that as a resource, we talk about and use this a lot because we talk about a lot of older classic games like Mario or Zelda or Pokemon, all kinds of different titles. Pong being sort of the first huge game, but not using sprites, so it's a little bit simpler in that we're only using basically rectangles and text. But what we want to do is we want to avoid this problem we're having where the game is very clearly not rendering things at a sort of zoomed in retro old style resolution. Things are being rendered at a native resolution. If you're on a 1080p monitor or a 4K monitor, it's going to be really small. So we're going to address that issue by using a library that I'm a huge fan of. I posted the link in the chat. So if you download the zip therein and grab the push.lua file that's in there, and you just put it into your folder where your main.lua is. So I actually have it from the prior version of the seminar. So I'm just going to copy it from there and paste it into my live2 folder here. You can see there's a lot of crazy stuff in here, and we're not at all going to be looking at this file. This is just a essentially black box of functionality that we're going to import into our project to give us the ability to have 1080p or whatever size windows, but we're going to pretend like we're drawing at the resolution of something in the era of Super Nintendo or Pong, something that's pixelated and zoomed in that looks retro and crisp. So to that end, we're going to use a library that accomplishes that, because ordinarily that would be quite a bit of work on our end that we don't necessarily have time to cover. So in order to get this working, I'm going to need to do a few things. I'm going to define a few variables. So I'm going to say virtual width is equal to 384. And variables, if familiar from CS50, from using languages like Python or JavaScript, basically a name of something, give it a value. In this case, virtual width is given the value 384. I'm creating a resolution that mirrors something that I would see from back in the day, albeit in this case 16 by 9, whereas 16 by 9 wasn't really standard back in the olden days of the Atari and the Super Nintendo and whatnot. These are going to be our virtual resolution, our virtual axes of resolution. And I want to also define what our literal window should be on our screen. So something that's much larger than 384 by 216, because that would be super tiny looking at it on my monitor. I want to do something like 1280 by 720. Since I'm using window scaling, this is the largest 16:9 that I can really do without it going full screen, which I don't want it to do, even though I'm on a larger monitor than 1280 by 720. So I've defined 4 variables there, 2 that represent our virtual width and height, and 2 that represent our actual window width and height. And then in addition to that, I want to also say push is equal to require space and then the string push. And what this is going to do is it's going to import that push.lua file that's in our directory. It should be, again, in the same directory as your main.lua. It's going to take the contents of that Lua file and put them into this push variable right here. So if you're familiar with JavaScript or Python, it's the same thing as a require or an import from those languages. And then I can do a few cool things following that. I can type in my love.load, I can do push colon setup screen. Colon is a specific operator in Lua that effectively allows us to simulate sort of class-based programming or method calls, which you might be familiar with from other languages. Don't worry too much about that detail for now, but you can think of it currently as very similar to the dot operator down here that we see in love.graphics.print. And we will only really be using this for push. So push colon setup screen. This is going to set up our screen to be a different virtual resolution than a physical resolution. So we're going to say, we're going to pass in our 4 variables that we just defined: virtual width, virtual height, window width, and window height. So this is going to set up our screen to be this way. Now, additionally, we also have to tell push when to render. So we have to say down in our love.draw, I'm going to say push colon start and push colon finish. And that's above and below, respectively, the love.graphics.print function that we called before. Anything that we draw has to go within the push start and push finish function calls or method calls, really. So don't worry too much about the technical details of colon versus dot. It's not super germane to what we're talking about, but just know for push, specifically, it has to be colon, and anything with love has to be dot. It's going forward. And this is actually the end of us using push to do anything. We won't touch it again, but just for now, that detail might catch one off guard. So if I hit my shortcut now and I run the game, you can see that not only is the window stretched to be 16:9 aspect ratio, but there's also the text being rendered much larger on the top left of the screen, albeit very blurry, which we'll address here in just a second. So I'm going to go ahead and take a look at the chat here. All right, is the colon unnecessary? Their official instructions, at least prior, used to be that you would need dot, but they may have updated the library to not. So let's see if that works. Nope, you do need the colon for reasons that are too technical for this conversation. Effectively, there's a way to simulate object-oriented programming, if anyone's familiar, in Lua, using things called meta tables, and it gets to be a little in the weedsy, but in this case, push does use those. It does use that style of programming, unless you're referring to semicolons, in which case, in other languages, folks might have used semicolons, or folks might have used, for example, C or Java, and in which case you need a semicolon at the end of a line of code to end the line of code officially. Lua is special in the same way that Python and JavaScript are, in that semicolons are not necessary. So you can have a line like this where a semicolon is not needed whatsoever, which I'm personally a fan of. I don't like semicolons a tremendous amount, but obviously that's an aesthetic detail that some folks might disagree on. But that is the gist of it. Karina asks, what's the advantage of emulating OOP instead of just using OOP? So in the case of Lua, there aren't really objects that are built into the language. Well, there kind of are. They do object-oriented programming in a kind of different way than what's normal They effectively do it using what are called in JavaScript prototypes and in Lua metatables. And in languages like Java, things are done sort of internally, just a bit different, using dispatch tables, in particular with C++. There are a lot of technical details involved that one could debate whether or not something is true or not true OOP, depending on which implementation something uses. But in the case of Lua, its object-oriented programming is prototype-based and is a bit different than what typically people associate with standard object-oriented programming in the style of C++ or Java, which are the sort of the two most common object-oriented programming languages. If you're familiar with JavaScript, it's very similar to JavaScript. Oh, somebody is saying I forgot a. Don't forget to replace the dot with a semicolon on line 22. Oh, in the case of this, there is no need to replace the dot with a semicolon. All love.graphics or love.whatever things are dots. There is no need to do it with a colon, but in the case of push, everything does need a colon. So my pleasure. Justin, you have spelled love incorrectly in your code snippet there. You have spelled it LVOE, which will definitely cause issues. All right, so we'll go ahead now and move forward. Jonathan says, are those virtual and window on top variables? Yes, these are variables. And specifically, we're using a convention with these. Lua doesn't need you to specify types in the same vein that other languages like C and Java do, where, for example, you would say int window height is equal to 720. In Lua, everything is dynamically decided when you assign it. In this case, for that reason, we need to sometimes be a little bit more specific about what we're using variables for with other means. In the case of something that's never going to change, for example, these resolutions or other potential values going forward, we need a way to signal, or should desire a way to signal, that these variables are, in that sense, constant. And to that end, we use capitalization and underscores as a convention to show that. We can define other variables in other ways. For example, we could just as easily have set window height in camel case is equal to 720. But that would then sort of imply that value might change in the future because it uses standard variable I guess, case, right? Different from the capitalized and underscored case, which there's a term for it that eludes me currently, but there's a name for this type of capitalization. But yes, those are variables. Anything in Lua that has equals something, so push equals require push, that is a variable assignment. In this case, all of these are variables that are numbers, and push is getting assigned the contents of another Lua file. And then you can have all kinds of different types of variables, and they're all dynamic. So you don't have to specify what type they are like you would in C or other languages. So let me go back to my slide deck just to make sure that I haven't gone too far forward here. No, it looks like this is a great time to start talking about the 2D coordinate system. So far, we haven't done anything super interesting besides drawing text to the screen. But the sort of core of what 2D game development is in a visual sense is the manipulation of things in a 2D coordinate plane. In this case, we have an origin that starts at the top left of the screen. And this, you can visualize this as being our monitor. It starts at 0, 0 at the top left of the screen, with X being positive towards the right, negative towards the left. In this case, it would be off screen, and Y being positive going down and negative going up above screen. And anything that we want to draw to the screen, therefore, needs to have an XY coordinate pair. So we do this in various ways in Love 2D. And the simplest way that I might be able to illustrate this is by getting us towards the goal of drawing, if we look back here at our image of Pong, by starting off by drawing this top left paddle, which we haven't drawn yet. We have only drawn a little bit of text. So let's go back to our code. Let's rerun it just so we can see where we left off. So we have a 16:9 window, and we have hello world being rendered very blurrily at the top left of the screen. That's not as desirable. So what I want to do is I want to fix the issue of this blurriness, which is another last visual step before we can start getting into some of the more interesting stuff. And we do that using this function that I'm going to put into love.load, love.graphics.set default filter that takes in nearest and nearest. And so what this does, so with love or with love 2D, anytime we draw anything, whether it's text or sprites, or in other words, artwork, image files, to the screen, it gets interpolated. It gets smoothed out, whether we're scaling up or scaling down. And by default, it uses, I believe, bilinear filtering, which is a way of looking at all the pixels as it zooms in or out of something and filling in the gaps to make it look smooth. If you've zoomed in on, for example, a picture or some text in Photoshop or something, you've probably seen this. It doesn't look super crisp all the time. Usually there's some smoothing of edges. We don't want that smoothing of edges in our example, because we're trying to imitate what something looked like back in the day, back in, Pong or Super Nintendo, Atari era. So to do that, we override the bilinear filtering by saying we're going to set the default filters to nearest neighbor filtering, which essentially just it calculates depending on whether we've zoomed in or out. Don't do any interpolation or filling in blanks of color values. Just take whatever the literal color value would be if you magnified or demagnified that texture or that font, which results in everything being magnified pixel-wise perfectly without any interpolation. Everything looks very crisp, albeit pixelated. So now when I run that example, you can see at the top left, our hello world, it looks a bit crude in a sense, but it's not blurry. We can very clearly see it in all of its pixels. If you were to zoom in on that last example in Photoshop, if you were to take a screenshot of how it looked when we very first did it, back when we ran our first example, when it was really tiny and zoomed in, this is effectively what you would have seen. And it's scaling it up now, doesn't interpolate it. It makes it look nice and crisp. So that is how to get past that issue. Gene, if you're having an issue with push, do make sure that you have required it. So push equals require push at the top of the file, and that push.lua is in your directory. And then Jonathan asked, why does it take 2 arguments? Because this applies filtering to both upscaling and downscaling things. So if it's upscaling it or downscaling it, we want it to both take nearest neighbor interpolation. You can actually set it to be different filtering depending on whether you're up or downscaling it. And if anybody's interested or curious about any of the sort of Lego boxes, the namespaces, as I'll refer to them, or the modules, the love modules, if you go to the wiki main page on the left side here, you can go over to something like love.graphics, for example, and you can look at all of the functions that are built into the love.graphics module. And as you can see, there's an awful lot. So set default filter right here. We can have it takes in a min and a mag parameter. And as you can see here, it shows you that's a filter mode for both of those, used for scaling the image down and then scaling the image up. And it says image, and we're using fonts because it behaves the same with fonts, which are image-based typically. So this is where the wiki is where you can get a lot more information on a lot of the details as related to all of the stuff that we're going to be talking about today. If you're curious, if you want to know different ways of using Love 2D, even given just what we've talked about, let alone many other modules and bits of behavior that you can take, there's a massive set of functions and behavior that you can explore, which can be quite fun, especially if you're brand new to the world of game development, to do a lot of exploration. Could you please show me your push.lua file? So the push.lua file is going to be a lot of crazy code, but you're going to need to download it from a link that I posted in the chat, and I'm just going to post it one more time so that you can see where to download it. It looks like Big Dawes as well has kindly put it kindly put a link directly to the push.lua file, so you can just download that and put that into your directory, but that needs to go right beside your main.lua file. So awesome. Okay, perfect. So I'm going to close that push.lua. And so the goal was, okay, we got our text and we've got everything in the future that we render nice and crisp. What we want to do now is we want to work towards getting that first paddle drawn to the screen. So what I'm going to do up here below where I defined push, I'm going to say player one. I'm going to create a variable called player one. I'm going to assign it to a set of curly brackets, which means I'm going to assign it to a table. And a table in Lua really is the only data structure that exists beyond things like strings and numbers. And I'm trying to think if there are other primitives offhand, but really Lua is a very small language. There aren't really many primitive values. You're really dealing with, yeah, numbers and text at the core. And in addition to that, you also want the ability to sometimes have composite data. So a player, for example, player one, we don't necessarily just want, we don't want a bunch of, let's say, for example, we wanted player one X, equal to 10. Player one Y is equal to 100. Player one score is equal to 0. Having all of these different variables like this can be kind of messy and kind of unnecessary. But instead, we can do is we can say, I want to define a composite data structure. I want something that can encapsulate all of the things relevant to player one. And we use curly brackets to define that. And then within that, we say, we define all of the variables that belong to that composite data structure, this table, as it's called in Lua, that's the name of it, the equivalent of dictionaries in Python and objects in JavaScript. We can say X is equal to 10, for example, Y is equal to 10. And then now we have, instead of having to say player one X, player one Y, we have these internal variables. And now we can say player one dot X, and it will look inside this table and grab the X and the Y that belong to player one. So we've saved ourselves effectively a lot of unnecessary variable declaration, and we've cleaned up the way that we've just structured our data as well. Is this comparable to a struct in C? Yes, it is comparable to a struct in C. Now I'm going to, in addition, do a couple of other constants up at the very top. We have our players X and the Y, but we also need to know, for example, how big our paddle should be in this case, right? How big the players should actually be. That's important information to have. You know where they are, but also how large they are. So we can say paddle height is equal to 32 and paddle width is equal to 8, for example, as a spitball. And these obviously you could tune at your discretion. So now we have the size of what a paddle is. We have a player one object that represents where that paddle should go. The next step would be, of course, drawing it onto the screen, right? We have our data. We now need to make sure it gets rendered appropriately. So what I'm going to do is I'm going to replace this print hello world line of code here. And I'm going to use a function built into Love called love.graphics.rectangle, which takes in, as you can see, with Pixelbyte installed, you get an autofill on the parameters of that function. So you don't even necessarily have to go to the wiki if you know the name of the function to see which parameters that function takes or it expects. You can see that it expects a mode, an X, a Y, a width, and a height. And this mode is important because that specifies whether that rectangle should be basically an empty line rectangle or whether it should be a filled rectangle. In this case, we want filled rectangles. So I'm going to say fill, takes in a string value. I'm going to say player1.x, player1.y, that's the X and the Y values we want the rectangle to be drawn at. And then it takes in a width and a height of the rectangle. So I can say paddle width and then paddle height. I do that, and then I run the code. And you can see that indeed, at the top left of the screen, 10 pixels away from the top left, because remember, everything's relative to the top left, the rectangle gets drawn relative to its top left. So not only is the coordinate system relative to the top left, which is up here, or I guess up here for you, the rectangle itself is relative to its top left corner. And then it gets drawn 8 pixels wide by 32 pixels tall, as you can see right here. And now we have sort of bridged the gap a little bit towards the image that we have here with this initial starting point. Now, I want to see, I want to take a few minutes to allow folks to do what I've just done, but for player two. I want everybody to try and implement the analog of what we just did with this rectangle, but do the same thing using the same concepts, the same way of doing it to create this player two paddle drawn at the bottom right of the screen. So we're going to take about 5 to 10 minutes or so. And then once we've done that, we'll go ahead and resume, and then I'll go over my implementation for that, and then we'll forge ahead with some more details. But until then, good luck, have fun. I will be back in about 5 to 10 minutes. All right, back to talk about the exercise. So hopefully folks were able to tackle this one. And I realize some people are still getting their environment set up. So hopefully people are, everyone's able to follow along at this point. If not, again, post an ed, write in the chat if you're having any technical issues so that you can follow along. If not, definitely no rush. As David said before, there will be all of these videos as well as the code and other resources available after the fact, so you can definitely follow along later at your own pace once you've got things worked out. But for the time being, if you still want to follow along, at least conceptually, definitely happy to have you along. So in order to do what we just did, it's going to be very simple and very similar. we're going to say player 2 is equal to another table that just has its own x. So in this case, we don't want the x and the y to be the same as player 1 because we want this paddle to be drawn at the bottom right side of the screen. So what we're going to say is player 2's x is going to be equal to virtual width minus 10, which was our offset for x on the left paddle, minus the paddle width. Because again, everything is drawn relative to its top left. If we want it to be the same distance away, we have to also factor in that paddle width if we're drawing it from the right side of the screen. In addition to that, we're going to say y is equal to virtual height minus 10 minus the paddle height, which accomplishes the same goal, but on the x-axis. And if I run this, whoops, I got ahead of myself. We have to do the same thing as we did on line 35 here by saying love.graphics.rectangle fill, but pass in player2.x, player2.y, and paddle width and paddle height, just as before. And now if you run this, we do indeed see the other paddle being drawn at the bottom right of the screen. And therefore we have a sort of symmetrical and closer to our goal appearance of a game on the screen. So hopefully folks are following along here. There's one thing I don't super love about this, and that's the sort of harsh dark black background. And there's a better color fill color that I actually like better for that background. So we'll change that background really quick. And the exact numbers of it offhand, I don't 100% remember. So I'm going to cheat for a second. I'm going to go actually from the last seminar, it's right here. I'm going to copy this from our old seminar, and we'll close that and pretend that we never opened it. And then I'm going to put that line of code right inside draw above where we draw the rectangles. This love.graphics.clear. So what that does is it just clears the screen literally with one color, a color that we pass in as these 4 parameters here. So these 4 parameters are red, green, blue, and alpha, RGBA, which you might have seen if you've used software like Photoshop or if you've done any web CSS work. Essentially, all color on computers is derived from RGB triplets, 3 different colored lights that combine together to produce a different composite light, just using the laws of physics and optics. We can make basically any color using these 3 components, and then an additional intensity level, which is this last component here, this alpha component, which is how transparent the color is effectively. And in Love, normally we think about RGBA quadruplets in terms of values from 0 to 255, 8-bit values. And that's just normally how they're represented. But in the world of Love 2D, because we use OpenGL as a background and the way that the library has as a backend and the way that the library has changed, the framework has changed in the recent iterations. Previously, you could just give it the straight up integer values for your RGBA quadruplets. You could say 40, 45, 52, 255, and it would know how to convert that to the correct value. In this case, it expects a value between 0 and 1 for all of these floating point values. But Love2D changed and expects that 0 to 1 value now for anything using RGBA quadruplets. So to convert what was previously 40, 45, 52, 255 down to 0 to 1, we just divide by the upper bound on that value, which is 255, which has the effect of normalizing all of these values to be between 0 and 1. Because again, if it's 0 out of 255, it's just 0. And if it's 255 out of 255, it's 1. And anything in between is thereby an interpolation. So we do that, but we divide all these by 255 if we know what our RGBA values are, which are usually easier to think of and parse than values between 0 and 1. We pass that into our love.graphics.clear function and we run. And for some reason, it's not working because I didn't save, right? Definitely save your work before continuing. So once I have saved, we can see that the background is a less harsh black. It's a sort of gray color now, a sort of bluish gray kind of, which looks a little bit more similar to, I believe at one point long ago, I basically took a color picker on Pong and an old version of Pong and grabbed the color just so it looked a little bit more similar to it. and then I use that actual value in the distro. So that is a relic of that process. Gene says malformed number near 1.y. It looks like it's seeing something called 1.y. I would maybe make sure that you don't have a space between player and 1.y. That might be the issue there. Just looking at that excerpt. So now we have a nicer background shade of color. The next step that I would like to do to get us working with input, player input, would be to get rid of or fix the problem that I'm having every time I'm running this, where I have to go to this top right of the window and hit this X. I would much rather love to press something like escape or Q or any key to quit the game and not have to manually quit, you know, as I would in an application ordinarily using something like Control W or whatnot, which I could definitely do with, you know, I think even Alt F4 works with love. But let's say I want to just use escape for quick, easy access. We can accomplish this by using the love.keyPressed key function that we've had here this whole time, but we haven't actually used yet. So love.keyPressed basically fires every time we press any key on my keyboard. If I'm hammering keys, it's saying love.keyPressed key, love.keyPressed key, love.keyPressed key, but it's passing in that key that I pressed on the keyboard. It's managing that process and sending it to this function that I define, so that I can then decide how I want to react to those key presses, right? Currently, I'm not doing anything. So all key presses are just getting ignored. Nothing's really happening with them. But if I were to say, for example, if key is equal to escape, then love.event.quit. So I can actually check to see what this key is whenever this callback function gets fired by love2d. I can compare it because it's going to be a string value. I can say if it's equal to escape, well, just quit. Use this function in the love.event Lego box or namespace called quit. And then when you're using an if statement, we haven't really looked at if statements yet. The syntax is going to be a little different than you might be used to if you've coded in something like Python or C or the like. Instead of curly brackets, we have a then keyword and then an end keyword, much the same way that functions have an end keyword, which I don't think we've talked about yet. This is sort of a syntactical quirk of Lua's, in that it uses then and end for things like blocks and end in general for general blocks, and then for conditional blocks. So this is how we can get keyboard input actually implemented, at least in the sense of individual keystrokes being pressed at once. So if I run this and then I hit escape, the game quits, and now we know how to use single key press input in our game loop. So we've effectively now covered, in very simple terms, this process input part of our puzzle. The only thing we haven't looked at yet is the update game part of the code, which is actually going to be the next step in our sort of path towards Pong. Okay, Gene says attempt to call method setup screen. Do capitalize the S, Gene. It looks like you need the setup screen, that second S in setup screen. Basically, the screen's S needs to be capitalized there. Okay, looks like folks are kindly assisting and debugging, so I do appreciate that. Thanks to everybody who is chiming in. And Karina asks, is Lua case sensitive? Yes, Lua is case sensitive, very much so. So the next step is we've talked about input, we talked about rendering. Let's say I want to actually move the paddles. Now, the thing with key pressed, and this ties into what I mentioned previously about update needing to get involved in our input handling. Love.keyPressed actually only fires when we press a key one time. So when I press escape and then I hold it down, it doesn't keep telling the game that we've pressed escape. It only fires one time because it gets triggered only once per frame on a particular event, which is the on key down event that Love2D manages. It doesn't fire that event again if the key is already being held down. It's just kind of ignores it. And then once we let go of the key, it sends another event on key up, which will tell Love2D if we have any handlers for that to do some sort of behavior, right? Which we're not going to be dealing with key up at all, but we will be wanting to ask the game engine, the framework, is the key being actively pressed down right now? Because if I want to move the paddle up and down and I want it to be smooth, I want to be able to press S or W down and hold it and have the paddle move in that direction, or press and hold up or down on the keyboard to move the other paddle, for example. So we need a different function for that purpose. The first thing I'm going to do before I even get into that is I'm going to define another variable. Now we're going to get into a little bit of interpolation, or talking about sort of delta time and interpolation here for a second. Well, interpolation is a generous term. We're going to be talking about sort of calculating, sort of based on the amount of time between frames, how to move something. It's very simple, and we're going to be using dt, which someone had asked previously, to do this. But before we get into the details of that, I'm just going to create another variable called paddle speed. And this is going to represent our speed in pixels per second that the paddle should move on the y-axis. Paddles are locked to only being able to move on the y-axis. And I can do this by saying paddle speed is equal to, let's say, some value like 140. Just an arbitrary value, just came up with it off the top of my head. It could be anything, it could be 160, it could be 200, it could be 300. Obviously, the higher this value is, the faster your paddles are going to move. So this is going to be to taste, really, depending on how you want to balance your game. And this is a big part of game development, is figuring out what these magic numbers should be in order to make your game feel good. So this is tuning. This is what people refer to when they talk about tuning. Mechanics or other things in video games is typically adjusting these variables to get things to work or feel or behave in a more pleasant way. So using that paddle speed variable, I'm going to go back down to love.update dt. Now this is an important function. This represents that last piece in the game loop, which is that love.update that takes in a dt parameter. And what dt essentially is the amount of time in seconds that has passed since the last frame happened. And this can be higher or lower depending on how fast your computer is. If your computer is really, really, really fast, this will always be, 1/60th of a second, or whatever your refresh rate is. If it is slower, if your computer is having a hard time running the game, this will actually be a higher value because some frames will have gotten skipped. Your computer is just not fast enough to be able to render a certain number of frames in that span of time. So what's going to happen is this dt value will be larger. Now, what this means is we can use dt as a multiplier to enable us to move things consistently across different machines. If I multiply paddle speed by dt, and dt is higher or lower depending on how many frames have been dropped on one computer versus another computer, the paddles are going to move at the same rate, even though one might be chunked. It might be moving like as if it's lagging, and the other one might be really smooth, but they'll be in tandem with one another because they're going to be being multiplied or scaled by this dt value. This dt value gets calculated for us and passed into this love.update function, within which we can use it ourselves to do things like move our paddles. So in order to do this within love.update, I can say if love.keyboard.isDown w, then end. So this means that if we're holding down the W key, so this is another namespace, another widget box that Love has access to called keyboard, love.keyboard, which has a function called isDown, which will give us true or false, depending on whether W or whatever key we pass into this function is being held down. It'll give us the Boolean result of whether that's true or not. If love.keyboard.isDownW, then we can say player1.y is equal to player1.y minus, because we want to go up, we want to go in a negative direction, minus paddle speed times delta time. So whether we are on a super fast machine or on a super slow machine, that paddle speed is going to get, the result of however many frames worth of speed have elapsed. And once the number of frames in a second has passed, we will have moved paddle speed number of pixels on the screen, right? And that's how we get the pixels per second ratio of speed calculated. So that's if we press W, and if we want to move up, but let's say we want to move down, which would be S, we would do the same thing, but we say else if love.keyboard.isDown S, then, and we're going to do the same exact thing, except now we're going to want to move down instead of up, which means we need to add to the player's y value. We say player1.y is equal to player1.y plus paddle speed times delta time. And some folks might notice that we're doing essentially a self-assignment here with player1 equal player1.y equals player1.y minus paddle speed times delta time. Lua does not actually have the plus equals, times equals, divide equal, minus equal operator that other languages do, unfortunately. It's a shortcoming of the language. Maybe it's primary shortcoming because this happens so often, but it's something that if you do enough Lua programming, you get used to over time. But that is effectively why we're using this syntax instead of something that you might have seen in another language that uses a more terse plus equals or minus equals syntax. So Jovan in the chat there brought that point up, which exactly is definitely relevant and an unfortunate thing, but something that, like I said, you get used to pretty quickly. So if I run this, oh, and Chinmay says else if or else if as one thing. So there's a difference in that if you do else space if, it actually creates a new block rather than a separate condition that branches off of this first condition. The two functionally are equivalent, but you would need another end in there for it to work properly. Yeah, it can be an easy gotcha there by doing that. Normally that will cause issues there. So you want to do else if to be able to make it within this same condition here, this if else if end. A good question. So I'm going to run this and I'm going to go press W and S, and you can see as I press and hold those keys down, we do indeed have our paddle moving above and below the screen. And in order to do that, you know, it works. You know, we can just press W and S and move it. It'll move depending on how fast my computer's running. It'll interpolate it. It'll always make sure that it runs at 140 pixels per second. So everything works there perfectly. Would assigning a capital letter require the player to use shift with the key? You might have to do you might have to do a keyboard combination with that, in which case you would do something like if keyboard is down, W and love.keyboard.is down shift. That would help you there. Doing a capital W, I'm not sure it even recognizes capital W. I'm not sure. I haven't actually tested that. I would expect this to probably be more common, but that might be a convenient shorthand. I'm not actually sure offhand whether it works that way. Rosa asks, how do I write the code if I want to use the up and down key? And that is an excellent question because it's actually going to be the next exercise. So we're going to spend 5 to 10 minutes. I'm going to make it an exercise for the reader, for the viewer, for the programmer to do the same thing that we just did for player 1, but for player 2, and use the up and down keys instead of the W and S keys. So let's take a few minutes now to take a stab at it. And then once that time has elapsed, I'm going to come back and show you the implementation thereof. So good luck and have fun, and I will be back in a few. All right, so that one was probably a little on the easy side, but that's okay. We have a couple more challenges coming up that might be a little bit more challenging. If folks, that one was a little bit too easy. And if it didn't feel too easy, that's also perfectly okay. I recognize that some folks may not have a lot of experience coming into the seminar, and that's what the seminar is built for. So if you are struggling, completely normal, especially if this is your first foray into game programming or your first foray into something like Lua or a dynamic programming language. Definitely do not feel discouraged. Familiarity and comfort will come with a little bit of time and practice, I do promise. And especially if folks are still encountering technical issues or errors when they're running their code, also a perfectly normal, perfectly reasonable part of the process. Not a whole lot to say other than you get an intuition for how to solve those kinds of errors. I'm seeing a number of syntax errors and the like in the chat as we go on, and it reminds me very much of my early days getting into a lot of this stuff. So I 100% relate and do know that it does get better and easier over time. So the way that we do what the challenge laid out is super straightforward. Actually, it's almost identical to what is pasted up above here, but instead of W and S, what we're going to do is we're going to say if love.keyboard.isDown up, then else if love.keyboard.isDown down, then instead of W and S, we use up and down, literally up and down the strings. And then instead of player one, we're just going to say player2.y is equal to player2.y minus paddle speed times delta time. And the same thing down here, player2.y is equal to player2.y plus paddle speed times delta time. And that'll have the effect now of when we run the code and I press up or down on the keyboard, we do have the paddles going up and down. Now, I mentioned this in the chat because somebody had commented on it, but the paddles currently do move infinitely above the bottom and top edges of the screen. And this is normal behavior for how we've implemented things so far, because Love2D rather can draw anything outside of the bounds of our viewport because the coordinates do expand forever. But we may not have enough time, probably will not have enough time to talk about mathematically how to solve this, but effectively it would just involve making sure that our Y values do not go below 0 or above virtual height minus the paddle height in size. Relatively straightforward, but something that's a kind of a minor touch that we don't necessarily need to cover at the moment. How can you render something off screen? Is it rendering the act of displaying on the screen? My thinking was that when it is out of bounds, it doesn't render at all, just a curiosity. It does still render it, but it does not get displayed to the frame buffer. So you will have things that you like OpenGL's backend will still do the calculations of drawing stuff, but it will not actually show on your screen, but it still will perform a lot of the work that gets involved in doing that. There are optimizations you can make to prevent that from happening, and most engines try to strive towards not having that happen to avoid rendering things outside the boundaries of the screen and just doing updates that are outside of the screen. But that's beyond the scope of certainly this seminar, and that gets to be a bit more technical and challenging. But yeah, you can absolutely render outside the contents of the screen. It just will not get shown in the window, but it does happen. It does cost resources to do. Good question though. How does a programming language manipulate pixels? I only see them output text and ASCII to a console like C does. That gets to be a very complicated question, especially with modern computers, because there's a lot of steps involved between translating code into visual output on the screen relative to how it used to be. In the olden days, on something like a Commodore 64, which I know David certainly used in his childhood, and I have dabbled a little bit myself. You would be able to draw directly to a set of memory that was on the computer. You'd not draw to it, but rather you'd be able to say, I want to set the index of this. I want to set this memory address's value, some specific memory address set. I want to set a value within that memory address set to, or set the address of that to a value like, let's say, red, or whatever. And it used smaller color values too. Back in the day, you didn't have RGB color. You had palletized color. You'd have like a set of numbers that map to preset colors effectively. And by drawing directly to this memory, the memory was hooked directly into a frame buffer that spit out to your TV or to your computer monitor. So you actually literally manipulating the memory that mapped to the contents that are on your screen. And in DOS, it was kind of similar. You would have, at least with a particular version of DOS, you could write directly to a set of memory that spit pixels out to the screen using VGA, which was a standard for video cards of the time, and a set of standards, really. There was a bunch of different kinds. With modern computers, it's a lot more difficult to draw directly to the graphics card. There aren't really facilities for doing that super easily directly. You have to go through quite a bit of work using APIs that Windows or Mac make available to you, and typically you're exposed to it with something like OpenGL. OpenGL will have a compiled set of functions that use those libraries, those APIs, to interact with your video card to display things to the screen. And then when you're writing things to the screen in a simpler environment like Love2D or any other application or a window manager or the like, you're really using even something that's somewhat high level compared to drawing directly to the memory that mapped to the pixels that existed back in the Commodore 64 or the DOS era of programming. It's quite a rabbit hole, but it's kind of fun to dive into a lot of that old stuff if you're curious as to how the evolution of sort of video adapters and graphics and stuff has developed. But yeah, the simple answer is that it's not easy to draw directly to the screen. You have to go through a lot of layers of indirection to actually do it. It's easier in something like a video game console or an older computer that lets you write directly to the memory that's in the video card, or use an API that ties directly into the video card or the CPU, rather than doing something that uses a higher level API and abstraction that communicates with the video card. Okay, so that was a nice little fun historical aside. So that was effectively how we get our paddles moving, and that's the extent really of the input side of the game. We have a couple of things left with enter, pressing the enter key to go between game states, which we'll talk about in a little bit. But as far as the core of our input structure, it's really just up and down, W and S, to move our paddles as the game progresses. It doesn't really get much more complicated than that. That's the beauty of Pong. It's a very simple, very easy game to understand and to play. The next thing that we want to get into is we have the paddles set up on the left and the right of the screen, and they can move, but we don't actually have a ball. And so to bridge that gap, we want to start talking now about the ball. So let's go ahead and do that. I'm going to do it very similar to how I've done player 1 and player 2. I'm going to say ball is equal to a table that takes in an X. And we're going to say the X, I want the ball to be right in the center of the screen. So to do that, what I want to do is I want to basically say X is equal to virtual width divided by 2. But because everything's drawn relative to its left corner, this would make it slightly offset to the right. So what I want to do is I want to actually minimize, or I want to decrease its X position by half of its value, so that half is on the left side of the screen, and the right half of the ball's on the right half of the middle line going down the middle of the screen. So I'm going to say X is equal to virtual width divided by 2 minus, now we don't actually have this defined yet, so I want to say ball size is equal to 4. So that's just an arbitrary size for our paddle. It's just going to, or for our ball, it's just going to be 4 pixels by 4 pixels. That's why we don't have a width and a height. We just have a size. It's going to be a square. So I'm going to say now X is equal to virtual width divided by 2 minus ball size divided by 2. This will have the effect of drawing the ball 2 pixels to the left of the center of the screen. So 2 pixels of it will be on the left, 2 pixels of it will be on the right. It'll be perfectly centered. The same logic applies to the width. For the Y value, we're going to say virtual width divided by 2 minus ball size divided by 2 for the Y value for our ball table. So just an XY pair, just like our player 1 and player 2. Really not a lot new here currently. We're just making a new rectangle. And to that end, we're going to go down to our draw function. And below our paddles, we're going to say love.graphics.rectangle of fill mode. And it's going to be ball.x and ball.y. And instead of paddle width and paddle height, we're going to say ball size and ball size. Let's save that and run that. Oh, did I forget to divide it by 2? What did I forget to do? Oh, I accidentally called this virtual width divided by 2 instead of virtual height divided by 2. It's my mistake. So now it's perfectly right in the center. So yeah, if you're following along and you copied exactly what I wrote for ball, I accidentally wrote y is equal to virtual width divided by 2 minus ball size divided by 2, but it needs to be virtual height divided by 2 minus ball size divided by 2. And that is how we define a ball, how we draw the ball. And currently, it's not really anything new that we've explored. Nothing fancy with it. There are a couple of different things that the ball needs to do to behave. Those being that the ball should bounce off of the top and the bottom of the screen. The ball should also be given an initial velocity, right? We need to start talking about velocity. The ball needs an x and a y velocity, because let's say we want the ball to move in any random direction when we start the game. The ball needs to be, in order to move in a direction, it needs to have an x and a y velocity, or a speed that it moves on those axes, to give it a different vector of movement, right? A different speed. So we need to initialize it with a sort of random initial velocity, which we'll use a couple of handy functions to do. And then once it's moving, then we need to check, okay, is it gone past the top or the bottom edge of the screen? If so, we need it to bounce off of the bottom or the top edge of the screen. And then 2 more things left. If it hits the left or the right edge of the screen, it needs to then trigger a point being given to the other player opposite that edge. So if it goes past the right edge of the screen, player 1 should get a point. If it goes past the left edge of the screen, player 2 should get a point. And that's just generally the mechanics of how Pong works. You want to get the ball past the opponent's paddle such that it goes past the edge. Once that's the case, and once somebody gets to 10 points, that person's the winner. So we need code to check for the edges of the screen. And then lastly, we need, and this is the most complicated part, we need it to actually bounce off of the paddles, using a mathematical formula for collision detection, which will be the final piece of our puzzle. And that will be the most technically, I guess, sophisticated aspect of what we're doing. Even though it's relatively straightforward, it can be a mouthful, so to speak, in writing that function out, which we'll see in just a little bit. So to get us started, the first thing that we're going to need to do is give us that initial velocity. Currently, the ball is just static forever. It's not going to change its behavior or do anything, which is obviously boring. We can't play the game if we don't have a velocity. So what I'm going to do, I'm going to go to love.load here. And the interesting thing about random number generation, and we're going to use random number generation to do this, to give us that y or x velocity and give it to our ball. Random number generation, if you don't give it a different initial sort of seed value, it will always give you the same numbers over and over and over again. Random number generation is not random. It's seemingly random. It's pseudo-random. It will always give you consistent results given the same initial conditions. So in order to get around this, what games will do, what engines will do, is they will do what's called seeding the random number generator, SEED, giving it a different growth point to start from to give us different values. So given a different initial starting value, it'll always give us different random subsequent values. In order to do this in love.load, what we can do is we can say math.randomSeed, and then we're going to pass into that function os.time. And so what this does is it uses this built into Lua, both OS and math. Math is a set of mathematical functions. OS is a set of operating system related functions. So what this lets you do is random seed will take in a value and we'll pass that to the random number generator, which we will then call using math.random in a little bit. And in order for us to always have a different value for that random number generator, we're going to pass in this os.time, which is the number of milliseconds that represents our current time code. And this will always be different every time we restart the game. So in this way, no matter how many times we reset the game, it's always going to be different values, because this will always be getting larger and larger and being a different value. So this seeds the random number generator so that we can then use those random numbers and start the game and then have it be different behavior for the ball every single time we start. Jovan asks, what does OS mean? Operating system. So operating system function to get us the current time in milliseconds. This will query our operating system, say, what's the current time in milliseconds? It'll give it to us and we'll pass it into random seed. So once we've done that, what we can now do is get started towards getting those random initial velocities. So what I want to do in ball, I want to store those velocities as two values called dx. We're going to give them the value 0, and dy, the value 0, for delta x and delta y, velocity. These are positive or negative values that will represent the speed in pixels that we move on that axis in a second. Much in the same way that paddle speed was sort of our x velocity in the event that we are pressing down W or S. These are going to be the velocity for the x and y coordinates, axes of movement for the ball. In order to give it that initial starting value, we're going to say ball.dx in love.load. So this happens at the very beginning. Ball.dx is equal to math.random. And then this can take in an integer value, and it'll give you between 1 and that integer value. So we'll say 60. And then ball.dy, math.random, 60. So something between 1 and 60 for the delta x and the delta y. So this could be very, very low, or it could be 60 pixels. So either way, it's still not going to be super, super fast, but it will be potentially very, very slow as well. So there's a way that we can remedy this, which we'll see in just a second. Now, if you're thinking ahead, you'll realize that math.random is always going to be positive in this case, because it's always going to be 1 to 60. So no matter what, we're going to be moving on delta x and delta y sort of down and to the right every time, because that's, you know, if we're going positive x, positive y, that's always down and to the right. That's just the nature of those numbers being positive. So we also want there to be a chance for these numbers to be randomized. We want there to be a chance for these numbers to be negative as well, right? And we can accomplish this pretty straightforwardly. If we just say, if math.random2 is equal to 1, right? Because it'll give us a value between 1 and that number. And if it's math.random2, that means there's a 50% chance. So it'll be either 1 or 2. So we could flip a coin here and basically say, okay, if it's equal to 1, then we'll say ball.dx is equal to negative ball.dx, right? We have a chance to negatify the ball.dx on a coin flip. And we do the same exact thing below if math.random2 is equal to 1. So if, you know, given a coin flip, given a 50% chance, 1 or 2, ball.dy is going to be equal to negative ball.dy. Separate those just to make it clearer. So now we start off with a delta x and a delta y, and they both have a chance, a 50% chance to be negative. So we have an even chance to have a negative or a positive velocity on the x and the y axis. Now we have the balls x and y defined now, but we're not really doing anything with it. So if we run the game, for example, we'll see that the ball is still going to stay right in the center because we aren't actually moving the ball yet. We're not using those velocities at all to do anything. The ball just has those values now, but it's still staying still because we haven't actually plugged it into our update function. Remember, we have input, update, render. In order for things to get changed in the render phase, they have to get changed in the update phase. So in this case, what we want to do is similar to how we have the movement being calculated here with the key presses. We want to say ball.x is equal to ball.x plus ball.dx. And then ball.y is equal to ball.y plus ball.dy. So this will add the dx and the dy's worth to the x and the y. But then also, again, remember, we have to calculate this across frames, different frame rates. We need to interpolate this with delta time. So we multiply that dx by delta time. Anytime you do some sort of movement or some sort of interpolation over time, some movement over time, always make sure you're multiplying by that delta time to scale it relative to whatever your current machine is. So now if we start the program, we can see the ball started off with a negative, with a bottom left delta. So it's positive y, negative x. If I rerun it, you can see positive x, negative y in this case, and it was faster that time. You can see positive x, positive y, much faster on the y. Notice the steeper angle as it went faster down. And then another instance, we got a nice distribution here, negative on the x and negative on the y axis. So our ball moves correctly given that initial starting point, and it's random every single time. So it's dynamic. So that way our game's not predictable or boring. It's always going to be slightly different each and every time. So that's how we get our ball moving. The next step being, of course, okay, now the ball's moving, but the ball goes, if we just watch it, the ball goes out of bounds, and then we can't do anything with it. We should probably check to see, one, whether it's gone past an edge, and two, the left or right edge, and add a score to player 1 or player 2. And 2, it should check to see, okay, is it hitting the bottom or the top of the screen? If it is, we want to keep it in bounds, but we want to make sure if it's going up that it starts to go down. If it's going down, that starts to go up. We want it to stay in bounds until it hits the left or the right edge or a paddle, after which it should bounce back into the arena. So to that end, why don't we talk about adding score to the game? So currently we don't actually have score implemented, but it's very simple. All that we really need to do is add a score field to the player 1 and player 2. So we just start with score is equal to 0. Pretty straightforward. Just another piece of information that player 1 and player 2 keep with them. In addition to that, why don't we at the very top here, because I want the scores to be the kind of nice large fonts, why don't we use a new function called, I'm gonna do this below, let's do this below push here, actually. I'm gonna call it large font, and I'm gonna use the function love.graphics.newFont, which is just another love.graphics function that we have access to that takes in a number given that to give it a size, and it gives it by default, it uses, I think, Arial as the internal font, but you could very easily just sub in your own font file that you have in your project, and that will also create a new font at that size, which can be nice if you want to spice things up, make it look a little bit more custom. But by default, we're just going to use the built-in font, which I believe is Arial. Love.graphics, a new font of 32, being assigned large font. This won't change, so we're making it a constant. Same thing down below here, because if I create a large font, I want to go back to a small font. So I'm going to create a small font using the same function, and I'm going to make that a size 16. So now we have a large 32 pixel font and a 16 pixel font. So what I can do, if I scroll all the way down to where I'm drawing everything, and then right below all the rectangle code, I want to draw, let's do love.graphics.print, and then I want to print the score. So we'll say player1.score. So we looked at love.graphics.print before, and we're using the same function here. Only in this case, we're actually going to pass in some other parameters. We give it an X and a Y value. This we didn't do last time. So we can actually give it an X and a Y value. So I'll say player1.score, give it an X of, let's make it to the left of the center. So we'll say virtual width divided by 2, and then we'll subtract, let's say 36 or so, if I'm not mistaken, on the estimation for that. Same thing for the height. We're going to do virtual height divided by 2, and then we're going to subtract, let's say 16. So about half the size of the 32 pixel font. So that'll draw the player 1 score, and then love.graphics.print player 2.score, virtual width divided by 2. Now I want this to be to the right of the center, so I'm going to add, let's say 16 to that. Virtual height divided by 2 minus 16, so it'll be above the center of the screen by about 16 pixels. And then this will be drawing in the default font size. I don't want that to be the case. I want this to actually be drawing in the large font. So I'm going to call a new function called love.graphics.setFont, and we're just going to set to that large font that we created before. And just so that in the future, if we do any other text drawing to the screen, since this love.graphics.setFont applies basically forever until we change it again, I'm just going to set it back to love.graphics.setFont small font. So up until between large font gets called and these are called, these will be rendered in the large font. And then as soon as small font gets called, the set font to small font gets called, it'll get converted, it'll get switched back. Any following love.graphics.print calls will get drawn in that small font. So let's go ahead and run this. And you can indeed see that we have our scores here being rendered in the center of the screen, looking beautiful, looking closer to what our goal was from the beginning, recall, which was this. You can see our ball in the center, our scores, and a bit of other text that we actually haven't implemented yet, this pre-50 Pong, and then press enter. So why don't we do that next, actually? Because that gets into an important conversation about game state. So let me just make sure that I'm looking at the chat. It looks like people are following along okay. I'm not seeing any messages there, but if folks do have questions, feel free to chime in, and I'll definitely be taking a look at that. But if folks don't have questions, the next sort of piece of the puzzle that we want to look at, a really huge piece of the puzzle actually, is the idea of game state, or rather a state machine in the abstract, but as particularly applies to game state. Now, a state machine is essentially a diagram, a way of representing how something changes its state, literally what it's doing, what state it's in, sort of how it's represented in its current form. So for example, this can be thought of maybe as an example of a state that represents Mario in a game. You can see we have these squares here that are states, and these arrows that are transitions. For example, if we're in standing, so if we're in the standing box, if Mario's standing, we press B, which is represented by the text over this arrow here, we go into the jumping state, right? So now we've changed. Now we're in a completely different state. And if we press down while we're in the jumping state, we go into a diving state. Maybe he dives down to the ground and hits something, right? And a different arrow should probably be here, going back to standing, which says touches the ground, goes back to standing, even though that's not represented here. And there's an alternative branch from, if we go back to standing in the center, if we press down, he goes into the ducking state, right? Represented by the press down, going into ducking. And if we're in ducking, we go and we release down, right? Now we're back in standing. So this is kind of a simplified set of conditions and inputs that represent how Mario might behave in a game. The same idea applies to a game at large, right? If we're playing Pong, let's say we start up Pong at the very beginning. If we go back up here, this is a game state. We're in the title state, right? We have a title being displayed. We have the scores are set to 0. We have the ball in the center not moving. It says press enter at the bottom. The paddles are initialized, the top and the bottom right, top left and bottom right. That's the title screen. But let's say we press enter, then that transition, that press enter transition, should take us into the serve state. Now we're getting ready to serve the ball. The game is basically started. There's an arrow going from serve to press enter, which is play state, right? So now we're in play state, and the paddles are moving, the ball is moving and bouncing off of things. There's a transition that goes from the play state, which says ball hits left or right edge of the screen, and then a point, then gets added to the other opponent, their score. That arrow goes back to the serve state, right? Once the player has scored on another player, we should be back to serving the ball so that we have a chance to breathe. The score gets reflected, and then that basically loops. Now there's another arrow going off of the play state, which is score is greater than or equal to 10. And then that arrow points to a state called game over, right? Where then basically we display, okay, the game is over, player X won because they have 10 points. There's an arrow going from that to, and I realize I probably should have made a diagram to illustrate this, but there's an arrow going to the title state that says press enter, right? If a player 1 or player 2 has won and we press enter, we go to the title, and then we restart everything, including the scores getting set back to 0 from the very beginning, and that is effectively an infinitely viable game state machine, right? And effectively, that's what we need if we're going to try and have something more cohesive, something that we can actually play, that we can actually press enter and start and get to a certain score, and then restart the game when we get to a certain score. We need a way of representing that state. And so we're going to do that in simple terms in this seminar. The way that we're going to do that is essentially with just a string, with a variable that holds a string value, and then a set of conditions that we're going to encounter primarily in the update function that changes that state, and also in the key pressed function as well. So I'm going to, below all of the, the players and the ball, I'm going to say game state is equal to title, right? So this is that title state. So in the title state, the ball is stationary. There's some text at the top of the screen that says the title. There's text at the bottom that says press enter to play. And then once we press enter, then we go into the serve state. And once we go into the serve state, we go into the play state. The play state goes back to the serve state. and so on and so forth until we've completed the game. So what I want to do is I want to represent this title state visually and also functionally. So we can start with our update function. The most obvious thing so far in my mind is the ball moves right at the beginning. Right as soon as we start the game, the ball's moving, and that's just, we don't want that to happen. We want to start the game. It says the title. We hit enter. It's time to serve. We hit enter, and then we're playing. We want to be able to do it at our own pace. To avoid the problem that we currently have of it just starting without our permission, essentially, we're going to take this the ball moving on the delta x and delta y, and we're going to put that in a condition. We're going to say if the game state is equal to play, then the ball can move. Then the ball can use its velocity and move on the x and the y positions, right? If I just do that and I restart the game, you'll see the ball's right in the middle of the screen. It's not doing anything. That's because game state's equal to title right now. It's not equal to play. We haven't actually created the means by which to transition to the play state, but we will do that very shortly. One thing I want to also do to encompass the idea of the title state is I want to add some logic and draw to accomplish that. What I want to do is I want to say, let's do it right. Let's do it above the logic for the paddles being drawn and the ball, but after love.graphics.clear. Let's say love.graphics.setFont, right? We're gonna draw the title screen here if we're in the title. And actually, before I even do that, I need to check, are we in the title state? So if game state is equal to title, then, and only then, should I love.graphics.set the font to the large font. Then I can use a new function we haven't looked at yet, which is a fancy, helpful function for centering text on the screen. I can say love.graphics.printf for formatted print. And this takes in a text, an x and a y, a limit or a column size, and then in a line style. So left aligned, center aligned, right aligned. So let's say pre-50 Pong is the text that we want to render to the screen. I'm going to start it at 0, and I want to start it at 10 pixels below the top. But I want to center this text in the middle of the screen. So in order to do that, I need to say, okay, we're going to start at 0. We're going to start rendering at 0. And then the column size that we're going to center within is going to be the entire width of the screen. So virtual width. And then I'm going to, within that column, starting at 0, I want to center it. So that'll have the effect of centering that text within the center of the screen up at the top, 10 pixels down. And then following that also, I want to also do love.graphics.setFont, because recall, not only is there the sort of the title at the very top, but there's also at the bottom, there's press enter. So let's go back to the small font. And then love.graphics. Do the same thing, printf, but say press enter. And then I'm going to do the same exact thing. I'm going to say 0, almost the same exact thing. I'm going to say start at the left, go from the bottom about 32 pixels. We'll say virtual height minus 32. Our column size, if we're centering in the screen, should be, again, virtual width. And then I'm going to center this, right? And then once we've done that, we can then save this, which I did, run the code, assuming everything is properly implemented. And indeed, thanks to the magic of love.graphics.printf and automatically figuring out, given our text object and the size of our column and the alignment style, we now have perfectly centered text on the screen. Up at the very top, we have our title, and at the bottom, we have our press enter. And notice that it basically is the exact same thing as our original goal, albeit we haven't achieved all of the functionality just yet, but we have achieved visually what we've been striving for. So that has been accomplished. And we are checking to see whether we are in the title state to do this. So coming back here, and again, if anybody's having any questions, do feel free to chime in here. I'm not seeing any new questions as the last 20 minutes or so, but do definitely chime in if you have them. But I will keep forging ahead. So if it's title, if it's the case that our game state is equal to title, right? That's what this double equals, by the way, means thus far. In case this hasn't been super clear, I know folks in the last seminar wanted some clarification. Single equals being variable assignment, double equals being check to see if these two things are the same. Now what we want to do is actually transition us to that play state. So to do that, what we can do, and this will, in time, this will be the serve state and then the play state. But for right now, let's just transition to the play state so we can see that that idea of transitioning states. We're going to go up to or down to key pressed right here. So because we're just checking to see whether a key is pressed one time, we don't need to worry about using love.keyboard.isDown anymore. We can just say, we can use love.keyPressed. So what I want to do then is say, just in the same way that we did this if key is equal to escape, I want to say if key is equal to enter, or key is equal to return for if we're on max, then game state is equal to play. So once we're in the play state, if I press enter, we do indeed see that not only does the text disappear, but the conditional logic that we had set previously that checks to see whether we are in the play state fires and allows our update function to move the ball, to apply its delta x and delta y to its x and y velocities. So things are actively moving and adjusting once we have transitioned into that play state. Now, that's going straight from the title to the play state, but we also do want a serve state involved in that. And in order to go from the play state back to the serve state, we also need a another piece of functionality, that being checking to see whether we've gone past the edges of the screen. So let's go ahead and accomplish, I think, first the idea of, or the implementation of, checking to see whether or not we are in the serve state versus the play state. So why don't I go ahead and then let's create the serve state first, because this will help us, because we'll be able to work towards the next exercise this way. So I'm going to say down here in the game state is equal to play, I want to say if game state is equal to title, then let's go to the serve state. So game state is equal to serve. Else if game state is equal to serve, then and only then do I want to go to the play state. So if we're in the title screen, we're gonna go to the serve state. So it's gonna wait for another enter press, and it's gonna say press enter to serve the ball. And then if it's in that serve state and we press enter, then it's gonna go into that play state. And then we can work toward going back to the serve state from the play state once the ball is moving, once the ball goes past the left or the right edge. So why don't we do that really quick here? So if we're in the title state, we have this bit of code here. Now let's go ahead and add another bit of code that says if game state is equal to serve. This is going to be very similar to the code that we just wrote here for the title state, except I'm not going to use the large font up at the very top in printf. I'm just going to say love.graphics.set font small font, which should always it should always be the case that it's in small font, but just in case, I'm going to set it to small font, and then I'm going to say love.graphics.printf again. We're going to center the text up at the top in small text. We're going to say press enter to serve. And then we can basically do the same thing we did here for the pre-50 Pong text. We'll just say 0, 10. So start at the left, go 10 pixels down, do virtual width as our column size to center it within, and then make sure we select center mode. Since we're already using the small font, we don't have to revert back to the small font afterwards, just like we did here. And then that alone should get us to where we need to be. So let's go ahead and change this. Oh, I made a typo on line 79. Let's look and see where that is. Oh, I forgot then. So let's make sure every else if and every if has a then. My mistake. So let's press enter. Now, based on how I anticipate, this should, once we press enter the first time, the ball is not going to move. It's going to display press enter to serve. And then when we press enter, then it'll go to play state. Then it will start moving. So let's press enter to serve. And then now it's moving, which is great. So we have progressed now towards having a serve state, which is going to happen every time a point gets scored, so that we have a second to just focus, rethink, adjust. The next step that we want to do, though, of course, is, okay, we have the desire to get to that serve state, but there's no way to do it yet. The ball just goes on forever, doesn't check to see whether it's hit an edge, doesn't check to see what's gone past the left or the right. We need to actually implement that. So that's the next step, actually, is we need to see, okay, is the ball gone past the left edge? If so, okay, well, now we're back in the serve state. Not only that, but we need to add 1 to the score of whoever just scored on us, right? So if it's gone past the left edge of the screen, player 2 gets a point. If it's gone past the right edge of the screen, player 1 gets a point. The opposite player of the ball hitting that wall, that player gets the point. So this, of course, falls into update, right? Because this is going to happen on every frame. We want to check, relative to the ball's position. We want to say, okay, after the ball moves, like, is it past the edge of the screen? And if it is, okay, well, we need to change the state. And we need to change the score. We need to do both of those things. So I'm going to do the first bit here, the checking to see if it's past the left edge of the screen. And then the exercise will be to all of you to do the other side, to do the right edge of the screen. But first I'll do the left edge, so to illustrate how it should look, how it should work. Nada asks, will the scores always appear in the middle of the screen? Yes, that's by design, because that's kind of how Pong is. Notice that the scores are down here at the very bottom, not within any sort of condition. We're not checking to see if the game's in any particular state to render the scores. They're always just here at the bottom in draw. They're always getting rendered no matter what. And this is deliberate, but you could very easily make this conditional. You could say if state is equal to play or state is equal to serve, then display the scores up to taste. Completely your decision. But for the sake of the seminar, for the sake of the old school way of implementing it, the scores are always visible in the center of the screen. That's a good question, though. Okay, so I'm going to now make it such that when the ball goes past the left edge of the screen, we do the appropriate state changes and score changes. The best place to do this is it can only happen in play. So you might as well do that while we're in this bit of code here, this logic. We can say, then real quick, it looks like when I press the enter key in serve state, my ball does not move. Are you making sure that when you're in the serve state, the state goes to play? So if we're over in our key pressed, for example, if we're in serve, note that we're saying game state's equal to play. And then once game state's equal to play, recall that we have some logic here that says if it's in play, the ball should get its dx added to its x and y. Do make sure that that is reflected in your code as well, because that's the only way in which that will work. And then Diego asks, can you separate the Lua files like CSS, the style design, the functions, backend operation codes? Style-wise, everything's in Lua, so it's not, you're not going to really, at least not with, there's probably some libraries you could import in Lua that use something like XML or CSS style sheets or whatnot, and certainly with certain libraries do get into that territory, but generally with Lua you'll just be splitting your files based on their logic, based on their functionality. So you would, in a proper large game, you would have paddle.lua, ball.lua, and then main.lua, and then main would load the paddle and the ball logic, and those would all be encapsulated separately, and then you would load them all together programmatically. Styling is kind of a separate thing that fits more into the world of web design than it does game design. But certainly certain engines do take an approach to that using texture atlases and things of that nature. But that's kind of beyond the scope of certainly this seminar. And that depends on obviously your environment and how you like to work. But there's ways you can kind of accomplish that goal. What do you think if we change the color of the ball or the scores text not to be the same color? Hey, if you want to change anything, knock yourself out. That's how you learn to do stuff. In order to do that, you would just simply need to probably give these a different color. So you would say something like maybe RGBA equals, and then give them values here in player one and player two. And then you would come down here before you draw player one and player two, and you would do something like love.graphics.set color, which is how you change the global drawing color, which by default is white. If you set this color to something that you're storing in, let's say, player one or two, and then you make sure to set the color back to white after they've been drawn, they will effectively have a different custom color. You could absolutely do that, but that's outside the scope of this seminar, but certainly not super untenable for sure. Good question. Okay, so getting back to the topic of moving the ball or checking if the ball has gone past the left or the right edge of the screen, we can simply say if ball.x is less than or equal to 0, right, which is the left edge of the screen, then we want in this case, this is player two scoring on player one. So player two dot score should be equal to player two dot score plus one. We want to increment the score first off, and we want to reset the ball into the center of the screen. So we'll come back up to where our initial X and Y were for the ball. I'm just going to grab them from the ball right here. Virtual width divided by 2 minus ball size divided by 2, and virtual height divided by 2 minus ball size divided by 2. So these are sort of the center coordinates for the ball where you want it to be by default. And we want to reset it to be that when we've gone to the left or the right edge of the screen. So I'm just going to say, I'm going to copy that. I'm just going to say ball.x and ball.y is equal to these values, making sure to get rid of these commas from the table. So the score gets incremented, the ball gets reset. Additionally, we need to change the state. So the state's no longer play, the state should go back to serve. So we'll just say game state is equal to serve at that point. I'm going to reset until we get it going to the left, which we are fortunate enough such that it is going to the left. I'm going to wait for it to hit the left, and then boom. Once it did, notice that player two, their score got incremented to 1. The ball got reset to the center of the screen, and now we're back in serve, which is illustrated by the fact that it says press enter to serve at the very top of the screen there. So now we have the ability to go infinitely from play to serve and back, at least as far as going to the left edge of the screen. Now, there are a few pieces still left to implement. The first of which is, okay, the ball is able to get detected when it goes, or I should say that a point getting scored by player two is able to get detected when the ball goes less than or equal to 0, but we don't have the ability to check for the opposite, which is if the ball goes past the right edge of the screen. And that's going to be an exercise for everybody, the next exercise. So I want to go ahead and let folks try to implement that. We'll spend a few minutes here, and then we'll be back to illustrate the implementation of it in just a few minutes. But until then, good luck, have fun, I'll be back. All right, back to talk about the solution. I noticed folks in the chat brought up a good point about the fact that we are not actually changing the velocity of the ball on every serve, which is excellent. That is a crucial step that we need to take into consideration here. And that can actually be part of the reset ball sort of set of logic. Why don't we take a stab at that? First, I guess we'll go over the solution to accommodating when the ball goes past the right edge of the screen, and then we'll talk about resetting that randomized velocity. So we can just add to the this if statement that we created up here that says if the ball is less than or equal to 0 on the x, we'll just say else if ball.x is greater than or equal to virtual width minus ball size. Now we do this because everything is drawn relative to its top left corner. So it's not enough just to say that the ball is greater than or equal to virtual width, because this will only be true when the ball is completely gone past the edge of the screen. I want this to, let's say, trigger right as soon as the right edge touches the right edge of the screen. And so that's what subtracting this ball size does, is it effectively waits until that left edge of the ball hits 4 pixels to from the edge of the right edge of the screen, which means as soon as it touches the right edge of the screen effectively. So once we've done that, we can say, okay, player 1.score is equal to player 1.score plus 1. We can then reset the ball with this logic right here, these 2 lines that I used up here. And actually, same thing with this game state is equal to serve. Right, so let's test this before we forge on with randomizing the ball. So I'm going to go ahead, just see if it moves to the right. Nope, so I have to restart it. Okay, so it's going to still trigger even if it goes past the bottom edge. So we just give it a second. And there, it did it eventually. It's pretty slow, but now you can see it does work. Player 1 got an extra point added to their score. So we've done that, but yeah, as people have pointed out, it doesn't get reset every time we go back to the serve state. It's going to stay the same. So why don't we take care of initializing the ball with a random velocity, and we'll actually take care of resetting the ball's position at the same time. So I'm just going to take this code here, the 2 lines that say ball.x and ball.y equals the center coordinates of the screen. And let's come down to the very bottom. I'm going to create a new function. And this function is not a function that Lua knows about or Love knows about. This is going to be our own function that we use ourselves. Just our own function to help encapsulate some logic that we're going to repeat in a few places. I'm going to call it reset ball. And one of the steps is, okay, the ball needs to be given that initial XY, which is in the center of the screen. The other step is that it should be given a different random velocity every time that happens as well. And if we scroll up to the top, you can see that we have that logic already right here in love.load. So if I just copy that code and then replace that code with reset ball, which is calling the function that we just defined at the very bottom called reset ball. Scroll back down here, paste this in here. Now we have not only the position getting reset, but also the velocity getting reset on the X and the Y axes. I'm going to come back up a little bit. And then where we were resetting the ball's position, now if I just replace that with reset ball, and then same thing here, if I just replace this with reset ball, now every time we call a reset ball, not only are we going to get our ball placed in the center of the screen again, but our velocity is going to get randomly assigned, because you can see here, it's getting this random value or random value here, and then randomly it's getting assigned a negative value. Now, the one shortcoming so far of this randomization, which some folks may have noticed, is that it can be really slow sometimes, which can be kind of annoying, especially if we were to play this with somebody or with an AI. It would be really tedious. So to get around the fact that this is possibly going to be as low as 1, what we can do is we could say, okay, the ball's delta x should minimally be like, let's say 60. And then we'll add to that a random value between 1 and 60. And then the delta y, same thing, but we'll make it 30, right? Because the height is smaller than the width. It doesn't need to be quite as fast on the y-axis. So now it'll start with this random value between 60 and 120 or in 30 and 90, and then it'll flip it to be negative on a coin flip. So either way, we still have a negative value or a positive value randomly, but now it'll always be at least an absolute values worth of 60 on the x-axis and 30 on the y-axis. So this will be much more enjoyable to play, not as tedious if I restart it and try it out. Notice that the ball, it's going pretty fast that time, a little bit slower that time. So pretty fast, but still not quite as fast. But more importantly, I would say the ball is moving in different directions after every serve. It's not moving in the same direction every time. So that solves that problem. Now we do still have a couple of other big problems. Those being that it's not bouncing off the top and the bottom of the screen for one thing, and two, it's not bouncing off of the paddles. Excuse me. Now, I kind of wanted to leave this as the last sort of challenging exercise. And that being, I want to see if you guys can figure out how to get it to bounce off the top and the bottom of the screen. Now, sort of mechanically, the way that's going to work is you're going to want to check to see, okay, does it hit the top edge of the screen? If so, well, it's moving up. Okay, well, I want it to probably still move in the same X direction, but the Y direction needs to, instead of going up, it needs to go down. Or if it's going down and it hits the bottom of the screen, it needs to go up. So that just needs to change, right? So it's in a sense, it's going to be similar to the code we just used to check the boundaries of the screen here, right? But now we're doing something slightly different with the behavior of the ball. We want the ball to change its movement in a particular way. And I'll leave this as this will be the last challenge of the evening before we forge ahead with this, and then also the collision detection with the paddles. But I want to give all of you a shot before we show the implementation to see if we can pull it off. If this proves too challenging, no worries. Certainly this is there's a lot at once happening here if this is especially your first foray into game development. But let's take this as our last quick, well, not quick challenge. We'll give 5 to 10 minutes and then we'll be back and then we'll wrap everything up with this. But with this challenge, good luck. And I will be back shortly. All right. Hopefully that was enough time. I understand that challenge is by far, I think, probably the most challenging of the challenges so far. But if anybody was able to accomplish it, congratulations. Very impressive. And if not, obviously no worries. Especially if this is again one of your first forays into programming or game development. A lot of this is, or at least that challenge at least, is purposefully meant to kind of push the limit, I suppose, of what some people might be comfortable with intentionally. But why don't we tackle doing so here? So recall again, the goal is to make sure that the ball, if it is hitting the top or the bottom edge of the screen, that it bounces the opposite direction. So if it's hitting the top edge, it should go down. And if it bounces down, it should go back up to the screen. And Jonathan said, how did they make this in 1972? It was all hard wired circuitry, if I remember. It was mostly electrical engineering, and if I recall, it was all vector based using electron guns. I'm not 100% sure on the technical details. It's been a long time since I read about it, but they definitely didn't have Lua and high level 2D frameworks and modern computers to program it on. So kudos to I forget the name of the electrical engineer who did it. It wasn't Nolan Bushnell, who he was the owner of Atari, but it was somebody else that worked with him at Atari, or what was to become Atari. Yeah, very impressive project. But and what language did they use? Assembly. They didn't even have assembly to program Pong, if I recall correctly. It was literally like just electronics, like gates and manipulating an electron gun or something of that nature. It was even cruder than assembly. It was pretty insane. Thankfully, most games following didn't really have to or code things that way or do things that way. I don't think. Maybe the earlier arcade stuff, when Pong was really one of the only titles out. Some other, especially vector machines, maybe operated that way. But yeah, that was a different time, a different era. But getting back to the exercise, so we can just go ahead and put it kind of below where we had the logic for calculating the left and the right edges getting detected. It's very similar to the left and the right edges getting detected in a sense, just inverted, and we're not adding to the score or resetting the ball, we're doing something else entirely. And it's actually arguably simpler in a sense, if we think of it that way. So we can say if the ball.y, if we're gonna take the top edge of the screen first, if ball.y is less than or equal to 0, because remember, everything's relative to its top left corner. So as soon as the top left corner hits the top of the screen, then what we want to do is we want to effectively make the ball go from going up, which is what it's doing. Its delta y is negative. That's why it's going up in the first place. We want to set that to be positive. And the way that we do that is we just say ball.dy is equal to negative ball.dy. And then we say else if the ball.y is greater than or equal to virtual height minus ball size, then we do the exact same thing. Ball.dy is equal to negative ball.dy. And in fact, you could actually combo both of these conditions, this if balls dot y is less than or equal to 0, and, or in this case it'd be or ball.y is greater than or equal to virtual height minus ball size. Then ball.dy is equal to negative ball.dy, and save yourself maybe a line or two, but not a huge deal. This is more readable, arguably, split across two, especially when I'm zoomed in like this, split across two conditions here. So if I go ahead and run this, press enter, I might not be able to see it. Yep, it was outside of the bound, going too fast, but this time we can indeed see it. It bounced off the top. And there we go, bounced off the bottom. So we are very close now to the game being implemented. The only thing that really remains is that we don't have the ability to affect the ball with our paddles, right? The ball just kind of bounces off the walls and can score for us or against us, but we can't actually try to fight our opponent with our paddle. The last piece of the puzzle, so to speak, is implementing this in the form of what's called collision detection, and specifically a formula called AABB collision detection, or axis aligned bounding box collision detection. So I'm just gonna full screen this really quick. So the math behind this, the idea behind this is it's relatively simple geometry, but it can be a lot to write into a function, especially the first time. Even sometimes I will have a brain fart as I'm writing the function. But and typically you'll use if you're writing 2D games, you'll use a physics library that just has this built into it already and a lot more fancy stuff. But for the sake of this demo, since we're doing everything basically from scratch, within the context of Love 2D and all the facilities it gives us, we're going to implement this by hand using a simple function. So the idea of AABB is if you have two boxes, two rectangles that are perfectly axis aligned, meaning they're orthogonal, they're not rotated in any sense, you can guarantee the test for a collision by checking a set of 4 conditions effectively. Given any two rectangles, so this blue rectangle and this green rectangle, I can say, okay, if this left edge of the blue rectangle is to the right of the right edge of the green rectangle, well, I know for sure that there's not a collision. It's 100% physically impossible due to just the laws of space and geometry, right? If this blue rectangle is to the right of the green rectangle, no collision possible if it's completely past it, right? The left edge is past this green right edge, impossible to collide. The same logic applies to every other edge. So if this bottom edge of the blue is above the top edge of the green, not a collision. Right edge of the blue is to the left of the left edge of the green, not a collision. And the top edge of the blue is to the bottom of the green edge. I think I said all 4 of the edges correctly. I might have duplicated one of them. Essentially, if one edge is on the opposite side, so if this rectangle's top is below the bottom of this one, and so on and so forth, all, 4 different possible ways that could be possible, then it's not a collision. It's just not physically possible. So what we do is we say, okay, if it's the case that any of those is true, we don't have a collision. If it's the case that none of them are true, we have a collision. Notice that in this example here, where these two rectangles are obviously colliding, it's not the case that the blue rectangle's top edge is below the bottom edge of the green. It's not the case that the left edge of the blue is to the right of the green. It's not the case that the bottom edge of the blue is to the top of the green. It's not the case that the right edge of the blue is to the left of the left edge of the green. None of those are true. Anytime you have a collision, none of those criteria are going to be true. Therefore, if we just write a function that represents this, we can compare any two rectangles, for example, our paddle and a ball, or any paddle and our ball, either of the two, and then check to see, have we collided? If we have, then bounce the ball back, right? So that's effectively what AABB is, and it can be kind of a lot. I'm not a particularly mathematical person, or at least not super rigorously so. So I understand if some folks might need a couple of times to see that or to think on it a little bit to understand how it works. I certainly did at first, but it is really a simple sort of like physical, a physically apparent law that you can see that that we can make a nice simple function for. So I want to write a function that does this, that basically encapsulates all the logic that I just described. I'm going to say function collides, and it's going to take a paddle and a ball. Really, this could take any two rectangles. This could be R1 and R2, right? For the sake of simplicity, anything that has an X and a Y and a width and a height. Now I'm going to assume paddle and ball just because the player 1 and player 2 and ball objects don't have a reference to their own height and width, so we can't calculate the algorithm this way. We need to assume that things are a specific way, as we'll see, so that we can properly add the width and the height of the object in question to the formula. But generally, if you maintain width and height parameters in your rectangles, you can generalize this function to work with any two rectangles as long as they have an X, a Y, a width and a height. So we'll assume that it takes a paddle and a ball, so we can use this for either paddle. We'll say return. So return basically means from this function, when I call it, I want it to spit out a value back so I can assign it to something. So in this case, we're going to end up returning a Boolean value, a true or false value, to determine based on whether it's true or false that these two rectangles collide with one another. So we'll start with basically what we just described. So if p dot x is greater than b dot x plus ball size, right? So this represents the paddle being to the right of the ball completely, right? We're to the right, past the right of ball dot x plus ball size, right? Because remember, everything is drawn relative to its left-hand corner. So we need to check to see, okay, is p dot x greater than b dot x plus its ball size? If we do that, we know that the paddle is completely to the right of the ball and they're not interacting. They're not physically capable of interacting. Or p dot y, now we want to check to see, okay, is the paddle completely below the ball, right? Below the bottom edge of the ball. Okay, so if p dot y is greater than b dot y plus ball size, well, we know that that can't be the case either, right? They're physically not capable of colliding. And then if we check the inverse of this, if we check the same criteria, but for the ball against the paddle, so if we say or b dot x greater than p dot x plus paddle width, or, and again, same thing for y, b dot y greater than p dot y plus paddle width. Now we have a set of 4 functions that check to see whether the edges of the ball and the paddle are opposite one another. If they're, or rather, they are not, they're not intersecting. They're not capable of intersecting. We have accomplished all 4 angles this way. Now this will tell us that they are not colliding. We don't want this to be the case. We want this to return whether they are colliding. So we have to essentially negate this whole Boolean expression. So if any of these are true, it's going to return, it's obviously not the case they're colliding if the edges are past each other. So we're going to say return not this whole thing in parentheses. So this is a Boolean operation. We're essentially negating all of these conditions. So if it's the case that any of these are true, or rather that, yeah, if it's the case that essentially this whole thing is true, then not colliding, we can return false. But if they are colliding, this will be, none of these will be true. And so therefore, returning not on that will end up giving us false. Falsifying a negative gives us true. Falsifying something that's truthy gives us, of course, false. So that's the expression there. It's a little bit of a mouthful. There's a lot of, a lot there kind of the first time you see it or write it. So no worries if this doesn't make 100% intuitive sense. But good point by Karina, actually. Yes, it should not be paddle width. This should be paddle height. That's a typo on my part. Thank you. I appreciate that. Because that would have confused me. I would have been like, okay, this isn't working. Yes, make sure you have the right, you're using the right height and width variables as offsets. But yes, that is effectively the logic there. So don't worry if you're looking at that. It's even I messed it up. Don't worry if you mess it up or if it doesn't make 100% sense right away. It's something that you kind of just have to look at a couple of times and visualize and understand. But once we have that function, now we can say, okay, if we're in the play state, right? So we have checking the left and right edges. We have checking the top and bottom edges. Let's say if collides the, and it's paddle ball, if I remember correctly, paddle ball, okay. So if it's the case that player 1 is colliding with the ball, right? Else if it's the case that player 2 is colliding with the ball. So we have these 2 conditions. So if player 1's colliding with the ball or if player 2 is colliding with the ball. So if player 1's colliding with the ball, what we want to have happen is the same thing that happened when we hit the top and the bottom of the map. We want it to reverse course. We want to go from the top down or want to go from the bottom up. So what we do is we say the ball.dx should be equal now, not to what it was before, but to its negative, right? Because we want to go from left to right if we hit the player 1 paddle, right? We're bouncing in the opposite direction. Not only that, but we want to make sure that we're not overlapping the paddle after we do the collision, because depending on your system, if you jump ahead a frame or 2, you might actually be inside the paddle, in which case we want to make sure that we push the paddle or push the ball outside the paddle such that we're on the next frame, we're not colliding again, and we're doing it over and over and over again forever, basically, which is what would happen and does happen with physics sometimes. So what we're going to do is we're going to say ball.x is equal to player 1.x and then plus paddle width, so that we're completely outside and flush with the paddle, the x coordinate of that ball. And the exact same thing we want to do with the player 2. We want to say ball.x is equal to negative ball.dx. And then we want to say ball.x is equal to, sorry, in this line, ball.dx is equal to negative ball.dx. And then ball.x, we want to push this to the left of the player 2 paddle. Want to get outside the paddle and back to the left. And then after that, and with our negative dx, we'll be moving back towards the left. We want to say ball.x is equal to player 2.x minus, not paddle width, because everything's relative to the left corner. If we're going to flush the ball against the left edge of the paddle, we actually want to make sure it's to the the ball's width away from the paddle to the left, not the paddle. That wouldn't make sense, but the ball's width away from the paddle to the left. So we'll say minus ball size here, not paddle width. And then if we run this, and assuming, and then Jonathan brought up a good point. We should do the same to the top and the bottom. That is correct. Yeah, I forgot to add that. We should do that. Only via luck has it so far not been a problem, but you could easily run into an issue where your ball kind of like stays on the top edge of the screen forever and just kind of moves to the left or the right. If that happens, that's because you're not resetting the position of the ball's Y to be outside the outskirts of it. You're not making sure it goes back into the center. Now, if everything's going correct and I programmed that collides function without any mistakes, we should be able to bounce the ball back now. It's a little fast, but indeed it does work. So we're able to move it. It's going outside the edge. And now you can effectively play Pong, until somebody messes up. Now, there are a couple of things that we could add to this to make it more robust. For example, every time the paddle collides with the ball, we should maybe add to the dx a little bit, such that it goes faster and faster and faster and faster. Otherwise, if it's just the same velocity, well, it's going to be kind of boring and easy to just play forever. To do that, all you would do is probably times the dx by some amount, slightly more than 1. So like 1.01 or 1.02 is maybe a good starting point for that. And you could do the same thing here for the ball.dy. You could say ball.dy is negative ball.dy times 1.02 or something of that nature. You would do it slightly more for the x, probably like 1.04. But this is more tuning. This is more to your taste, right? You're slightly increasing the dy every time you bounce off the walls or bounce off the paddle. The game gets faster and faster, so it gets harder to keep up. So that eventually someone's going to lose a point, because if it's slow enough, you'll just play forever and it won't be challenging. So the goal is to obviously make it faster and faster. The last piece of this puzzle, and we have just enough time, I think, probably to accomplish this, is that we need to make it possible to get to the loss state of the game, or to the win state of the game. So what we'll do is when we add to the score, which is right here. So when the ball gets past the left or the right edge of the screen, and then score gets added. So if score is getting added here, and if it gets greater than 10 or what have you, then, or maybe for the sake of easy illustration, we'll say 3 just to test. But we'll say we'll do it after reset ball. We'll say if the player 2.score is greater than or equal to 3, then we're going to set the game state equal to win. And then we'll say else game state is equal to serve, right? And then we'll get rid of this game state is equal to serve bit right here. So now we have a win state. We haven't programmed yet, but we will very easily be able to tie that into our other logic. We'll do the same thing here, except we'll use player 1.score, and I'm just going to go ahead and copy and paste that down here and change this to player 1.score. So add to the score in each case, reset the ball. If player 1.score, or if player 2.score is greater than or equal to 3, game state equals win, else game state equals serve. Let's go down to the very bottom. And in here, I'm going to say if game state is equal to win, love.graphics.set font to, this is mostly a rehash of logic that we've seen so far, but we'll make the font large. We'll say local winner is equal to, and this is a little trick that you can do in Lua. We'll say player1.score is greater than or equal to 3, and 1 or 2. So what this does is this is a shorthand for an if-then expression, essentially, or if-else, I should say. We're basically saying, okay, we want winner to be equal to either 1 or 2, depending on whether player.1's score is greater than or equal to 3. If player1.score is greater than or equal to 3, we're going to be giving winner the value 1. Else, we're going to be giving it the value 2. This is just a shorthand. This is similar to the ternary expression that you might have seen in C, where you would use colon and or question mark colon. It's the same exact idea. And this is a Lua form of a ternary expression. And then what local does is that's just how you define a variable to the scope in which you're defining it. So in this case, we're just making a variable within this if statement. We're just saying, okay, if game state, blah, 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 create a variable called winner that's only visible inside here. And then once this if statement's over, this local variable is gone. It no longer exists. This is similar to how variables typically work in something like C or Java, where it's only accessible to the scope in which you define it. By default, variables that you define without local are always available everywhere in your entire project. So it can be kind of dangerous to not have local on a lot of variables, unless you know for sure they're going to be global. So be careful. Do use local more than not, especially if it's only within a limited area. That's the better practice to approach. Globals are generally harder to manage than local variables. Following getting the correct player that won, basically checking to see if player 1's greater than or equal to 3, then obviously they're the winner. Else 2, if we're in the win state, somebody has won. So we need to decide who won, and then we're going to say love.graphics.printf. We're going to say player space dot dot winner dot dot space wins. Now this dot dot we haven't seen yet. This is how you add strings together. You can't just do player plus winner plus wins. Unfortunately, like you can in a lot of other languages like Python and JavaScript, you actually need this dot dot operator. You might have seen something similar if you've ever looked at PHP code, for example. Different languages have different string concatenation operators. But if you're adding strings together, you have to use dot dot, another sort of Lua quirk, so to speak. And then we'll just use the same centering bit of code that we used up here, this 0, 10 virtual width and center bit to make it perfectly centered in the screen. Following that, let's go ahead and copy the small font and then press enter. And paste that down below here. And we're going to say press enter to restart specifically to make it clear that we're going not from the win state to the play state or what have you, but we're actually going back to the title screen, right? And then the last step, so we have this logic in here, this game state equals win, conditionally rendering some text showing us which player won. The last thing that we need to do is also come up to the bit of code in love.keypress where we're pressing enter, and we have to account for the win state. So we're going to say, we're going to add an else if game state is equal to win. Then we're going to set game state all the way back to title, completing the loop of states that gives us a cohesive game. And not only that, once we go back to the title state from the win state, we also need to reset the scores. So player 1.score is equal to 0, player 2.score is equal to 0. Otherwise, they'll just have the same score as they did before, and then they'll just automatically win immediately. So that won't be super helpful. Let's start the game. Let's just sanity check to make sure everything works as intended, assuming that I didn't make any typos here. We'll try to purposefully lose to get somebody to 3 points really quick. If we're lucky, this next one will also go to the right. Nope, of course not. It is a normal distribution of random numbers after all, so perfect. So we got 3 points scored. It went to the right side. You can see player 1 has the 3 right here. It reset the ball, put it in the center. It says player 1 wins, press enter to restart. If we press enter to restart, the score should reset. which does indeed, and we are now back at the title screen, thus completing pre-50 Pong, or at least, as far as we hoped to achieve in this seminar. There are obviously things you could add to this and do, and actually that's the last slide that I have, or one of the last slides, is some optional things if you guys wanted to pursue some more layers to add onto this code. Clearly you could hopefully you were all able to hear me. Like my mic for some reason turned off during that. But some of the optional things that we could do after the the scope of what we've done here, you could add AI. So AI for one or both of the paddles. So this is actually GD50's first homework assignment, as you can see in here. GD50 being, of course, the game's offshoot course that I instruct. That goes into a lot more than Pong. Obviously, Pong is the very first lecture, but we go into things like Mario and Zelda. We go into Pokemon. We go into Unity. With Portal and some other games. It's a lot more in depth and a lot more diverse than certainly this one lecture. But this is the first homework assignment in GD50. So adding AI to the paddle is a deceptively simple task, and in that doing it seems simple, but there's actually a lot of things you need to take into consideration to do it effectively. Things you could add that are not that homework assignment. For example, you could make the paddles images, sprites, certainly by looking up things like love.graphics.draw. You could add music and sounds using love.audio.newssource. Of course, a lot of this involves exploration of the Love2D wiki and the framework itself to see where all these functions lie and how to use them. But the documentation is certainly very accessible and helpful to have. You could have a sprite-based background. You could have multiple balls that are all going at once. So that way, any one of them could trigger a point gain to make things a little bit crazier. Your paddles could adjust in size. You could choose before the game starts. You could have a way to adjust the desired point, the score to get to, right? So you could say, okay, I want to work towards 5 points or 10 points, 15 points. So make a UI to be able to change that number, set it, and make the game know that that's the limit that you want to work towards. And then lastly, you could make the collision detection more robust because currently, if the velocity gets to a certain speed, actually, we haven't accounted for this, and it's fast enough, it could actually go more than the paddle's width distance in one frame, meaning it'll completely skip over the paddle, and so it actually won't collide with the paddle, even though it goes through the paddle. So to account for this, you check to see, okay, is the distance between the last frame larger than the size of the ball? If it is, figure out how many chunks of that are basically the ball size, and then do a collision detection for each of those. And then if any of those are a true collision, then you've collided, and therefore you can go as fast as you want to. It'll just figure out that, okay, I've gone more than a ball's distance of collision. I need to interpolate. I need to figure out every single chunk of that and see whether I skipped over a paddle altogether, right? But that is pre-CS50 Games Edition. I would love if anybody can submit some feedback. So cs50.ly/feedback. I'll post this link in the chat here. We do appreciate any and all feedback of this seminar. Certainly helps me, and it helps the teaching staff as well, so we can make CS50 a better ecosystem. I want to thank everybody for coming. I'll stick around for just a few minutes here if anybody has questions and that they want to post in the chat. I would be happy to stick around to answer them. Thanks everybody who's already saying very nice things. I appreciate it. Thank you so much. Yeah, in response to Karina, yeah, it's a lot of material, especially if folks are brand new to game development. This can feel like a lot. It's kind of deliberate. Like, we purposefully bit off the entirety of Pong because I, at least personally, pedagogically feel like it makes sense if you're trying to learn how games work to learn how an entire game works rather than just a small little thing. Because now all of you could presumably, at least in the realm of shapes, go out and do a lot of stuff because you know how to make an entire game, literally an entire game in Love2D. But had we just talked about graphics, or just talked about sound, or just talked about one small little thing, there would still be a ton of holes, I think, in everyone's knowledge, at least if folks were unfamiliar to start with. So I think, despite how much material it might have been, I think it was probably for everybody's benefit, at least in my opinion. So Everybody's saying thanks. You are fantastic. Thank you very much. I appreciate everybody's kind words. It was my pleasure. Thanks for everybody tuning in, especially for some folks. I know this is kind of a later time slot too, although folks are definitely chiming in from all over the world. So in some people's time zone, it may not be super late. It's 9 p.m. for me. I know folks in Cambridge on the East Coast it's midnight for them, other teaching staff. So yeah, and if anybody has any questions related to anything we talked about, technically or conceptually, or anything germane to games or anything or whatever, we'll stick around for just a few minutes here to cover that. Sorry, this is you made in my morning. Appreciate that. That's kind. Appreciate that. Justin says, my ball is still moving so fast. Can I change it to slower? Yeah, sure. If you just adjust the velocity, that starting velocity on the X or the Y to be some lower constant, not 60 or 30, but maybe a smaller value. Make sure you're multiplying by dt as well, because if you're not multiplying by dt, you're literally every single frame adding that speed in pixels to the ball's position. So you're going to be moving 140 pixels every 1/60th of a second, which is not going to be, or however many it is in dx and dy. So it's going to be pretty nutty. You want to make sure that anytime you do any movement that you multiply it by dt, any velocity-based movement. So do make sure you're multiplying by dt. And also, the code that we did today will be on GitHub. I did post the GitHub repo previously, but let me post it again. And I'm going to make sure to commit the changes that we made today. It'll be in a folder called Live 2, because today was the second seminar, second iteration of this seminar. So it'll be in Live 2. It's not up yet because I haven't committed it yet, but give it like 10 minutes. I'll do it as soon as this seminar is concluded. Somebody asked, where can I find more practice? I recommend the course that I instruct, GD50. You can watch all the videos for free. It's on edX as well. It goes into a lot more detail on a lot more topics than just Pong and shapes and rectangles. We basically do what we just did here, but a different game every week. We do a bunch of games. We go into Mario, Zelda, Pokemon, Flappy Bird, yeah, what have you, all kinds of games. So it's a little bit for everybody if you're a fan. We even go into 3D stuff towards the end, although not in super tremendous detail, but we use Unity if you're interested in that at all. So do check that out. And optionally, the best practice, figure out if you want to make a game and make it. Just kind of like figure out, okay, I want to make this game. How do I do this thing, this small thing to get me, bite off a small piece at a time. Depends on your aspirations. Obviously, an individual probably can't make something like a big Grand Theft Auto or World of Warcraft game right away, but try to bite off smaller projects that sound fun and do a small piece. And then the more of that you do, the more you use Google to fill in the blanks. You read through the documentation of Love2D. You go through Reddit and forum posts and Stack Overflow and all the resources that are available to modern programmers. Thanks to the beauty of the internet, you'll be able to basically figure everything out. Join Discord groups, join Facebook groups, do whatever you want to whatever you have to do to understand. Is there a link to the slides? Yes, there is a link to the slides. If I copy this link and post it in here, you should be able to see the slides there. In the course, do I use the same software? Yes, we use Love2D up until we teach the Unity stuff, in which case we transition to Unity. Still use VS Code for the editing personally, but Unity you can just hook up to whatever text editor you like, and that will it'll suit your needs. Unity is a much more visual oriented workflow for a lot of stuff, but you will still need to get your hands dirty with C# code, and you will need a text editor to do that for most things. So Sart says they already joined and is on Portal. That's awesome. That's basically the end of the class. So good job. For a game like GTA 5, can you access some of the source code? No, Rockstar's code is not accessible to the public. There are open source games, but yeah, not commercial software does not tend to be open source. Very, very rarely. id Software is pretty good about that. At least in the past, they made like Doom and Quake and a lot of their games open source. But yeah, nothing big like that's going to ever be open source. Companies seek very hard to keep their code private, because that is how they make their money. And it only really does it after, after they've made a ton of money off of it. Like they made Doom and Quake and whatnot open source, like a while after they had already made a lot of money off their technology. And they licensed their game engine, id Tech engine as well. So having the code is of benefit to developers licensing their engine. So they had even commercial incentives to do that too. Although I think that was less a part of the equation. It was more just because they do believe in sharing stuff. As for whether they use open source stuff, probably, honestly. That I wouldn't know. Obviously, a lot of companies are going to have their own in-house engines, which are going to use licensed widgets and whatnot, but not. Yeah, that's going to vary company to company. Certainly at least some open source software, right? Like GCC for compilation for C and C++. Obviously, they're going to use stuff like that, but they're not going to use higher level tooling. Their higher level tooling is not going to probably always be open source. Some of that's probably going to be private, closed source. PS5 games created by the same. So Justin's asking, are PS5 games made in the same style as this? Not specifically. So the PS5, every platform is going to have a different way that it exposes its API. So Love 2D, I've seen it ported over to a couple platforms. Like I think somebody made a Switch port for it. You're going to typically be kind of you're going to be at the mercy of whatever that platform has decided it wants its API to look, what tools it wants to make available. Now you can, depending on how comfy you are and technical you are, you can kind of mold that in a way. I know that, for example, for Crash Bandicoot back on the original PlayStation, the developers did a lot of hacking of the game libraries and firmware and whatnot to actually do a lot of things that the PlayStation wasn't formally allowed to do. But they were like CS like engineers, like crazy, sophisticated, good at what they did people. And they knew how to kind of bend the platforms. I suspect it's less viable to do that now, but platforms now are also like x86 architecture. Like PS4 was x86, which is like what desktops are. So it's not Intel desktops. It's not as much of a problem now to get around stuff. Like the PS3 was notoriously hard to program for because its processor was very unique, and its GPU was unique, and it was kind of an ordeal. But I think they learned from that. That's why they made the PS4 a little bit easier to program for. But long story short, like you're still going to have libraries that you use functions in that are similar in concept to what we've talked about here, where you have the love.graphics stuff, the love.audio, the love.sound stuff, audio stuff. It's not maybe going to be as high level. Like you're typically for consoles and stuff, you're going to be coding in C++ or C. Not always. You can use a scripting layer on console as well, but you're going to be doing lower level programming, and you're not going to have always the luxury, because consoles, you're typically trying to squeeze a lot more performance out of the consoles than you are on a desktop. Sometimes, especially in the indie game world, which this is a little bit more catered towards, and for 2D stuff. And that also ties back into Unity and Unreal. Those compile for PS5 and PS4 and Switch and other consoles. So if you just use Unity or Unreal and you have a license to export for Xbox or PlayStation, then they take care of all that logic for you, and you code in Unity the same way that you would code in Unity on the desktop, right? You're exporting it to the PlayStation. You're not exporting it to to desktop. Can we create a game like GTA 5 in Unity? Sure. Yeah, your Unity is not limited in really any sense. GTA 5 is a very technically impressive game and framework, and it's built on many, many years of them iterating on their streaming technology. But it is, you could certainly do something similar, if not as technically maybe impressive, just because they have however many engineers. I mean, if you're talking about by yourself, probably not. But if you're talking about on a team, sure. Yeah, Unity's good enough to do just about anything. How does the game have online multiplayer? Using server client architecture. So you have a server on one machine and clients on other machines that speak to other machines, connecting either directly or to servers that connect to the other clients, sending packets of information back and forth. And you take in those packets of information and you change your game state to reflect the information that other people are sending you, and vice versa. You send updates with your state, and the clients and the server try to stay in sync as much as possible. And typically on your end, if you're a host, you have a server and a client, and your client connects directly to your server and speaks with it directly. How are modded games made then? Like GTA San Andreas has various mods. Nice to know how this happens. People will typically reverse engineer the code using decompilers and reassemblers, and actually kind of like figure out how the code works in using very limited knowledge. Because at the end of the day, all bytecode can be crudely turned back into source code, right? Assembly is, you can convert bytecode into assembly into high level code. You just won't know the variable names and comments and any of the stuff that they used in the original code, but you can certainly reverse engineer stuff. It's just it's really laborious and not a fun life. But I mean, well, it's fun. I should say it's fun for people that like doing that. Like it can be interesting. Some people love reverse engineering and figuring things out and hacking stuff. It is fun in that sense, but it can be tedious. Because you're literally kind of like not Rosetta Stoning, but you're like sort of deciphering this mystical arcane set of massive code, right? Because GTA 5 is tremendously large. What are the advantages of Lua against Unity or Unreal? No advantages per se. The advantage of Love 2D and Lua is that it's extremely easy to get up and running. It's extremely performance efficient for a 2D game framework. It's really lightweight. Lua is a really good scripting language. Lua is really common in the games industry as a scripting language, so you get experience using Lua. And its documentation is really good. Those are really the only reasons I would say why you would want to use it. But Unity or Unreal are better for larger scale, especially 3D applications. Love and Lua are really just for 2D games. This is a 2D game development tool. It's not really meant for 3D games at all. People have started hacking it to do 3D stuff, but it's not meant for that. They are for different use cases, in my opinion. But there are no advantages or disadvantages per se within the realm of 2D. It really depends on what are you more productive in, and what do you like better, because that's really where you're going to experience the ups and downs of a particular environment. What game engine does Nintendo use? Breath of the Wild. They use an internal engine. Not a whole lot of information is public about it. They don't use a specific engine that's like outsourced or licensed. They have their own tools and technology that they develop in-house, in much the same way that Rockstar does. To make a game, should one rather choose to program from Lua or Java or Python? Doesn't matter. Again, when it comes to language, like you should learn a bunch of languages and be fluent in them and understand them, know what they bring to the table, why they're good, why they're bad, or why you feel like they're bad at least. And then choose a framework that you like, that you feel comfortable in, that you relate with mentally, and then make something in that, and then make something in something else, make something in something else, and build up knowledge and comfort. Because depending on if you want to be a programmer in the real world, you might not get to choose what you program in. But Lua is a great language because it is super ubiquitous in the world of games. So I personally probably would advocate for Lua, but Java is great. Python's great. It kind of is going to be dependent on you and how your brain parses different languages and feels about them. How can I convert the Pong game we made into an Android application? There's instructions on the Love Wiki for how to do Android stuff. So if you go to the very I think in the getting started here, it should be some instructions. Right here, there's some Android instructions. So just go to the wiki getting started page, go down to the Android, read that. You'll have to, I think, download some code to get it working at the front page, although that APK stuff might be just to run love on your Android phone. Yeah, it looks like it's pretty straightforward, actually. Yeah, you just put the game folder on your SD card / love game. Love game may be just a placeholder title here. Yeah, it looks like it's relatively straightforward, just a couple steps. So yeah, just follow the instructions on the getting started wiki. I'll post it here. Oh, whoops, I just private messaged somebody I didn't intend to. Apologies for that. Which game engine does it tend to use? How much math is needed to make games? That's a good question. That depends on what you do. If you're a physics programmer, you need a lot of math. If you're doing like AI behavior, like scripting behavior at a high level, where all of the math and stuff is taken care of, and you're basically just like telling AI agents how to behave in a particular area, you might not need a ton of math. It depends. I would say the more comfy you are with math, probably the more advantages you have, depending on how flexible you want to be as a game developer. But I am not the best mathematician. Not that I'm the best game developer either. But I feel like I could reasonably get around without a ton of math until I need it to do something specifically fancy visually or physically, in which case sometimes you can need a bit of math, but also you can just use libraries that people have written, physics libraries, to take care of that, so you don't have to do it. Or you can look at the source code for those physics libraries and understand how it works. How to make the application into an EXE. I believe there are instructions for that on the wiki as well. I'm trying to see, was that on the same page here? There's definitely a way to do it. It involves basically turning the game and love together into either a .love file, or you bundle them together in a zip file, a zip folder in a particular way, or you take your game and put it into the game exe with a file. It's been a while since I've done it, but it's definitely possible to do it. Absolutely. You might have to Google turn love 2D game into exe, because offhand I'm not sure how to do it, and I don't see it on here on this page, but it's possible to do it for sure. Okay, I'm just making sure I haven't missed any questions. It looks like everything's caught up. So I want to thank everybody again. So this was fun. This was pretty smooth, I felt. Thanks everybody for participating. Yeah, and do reach out either to me or to Ed, the discussion group, if you have any questions. But this was CS50, and do submit the feedback form as well. We would very much appreciate that. But this was pre-CS50 Games Edition. My name is Colton Ogden. I teach GD50 again. It's on YouTube. It's on CS50, one of CS50's websites somewhere. It's on edX. Follow it if you enjoyed. And I appreciate the kind words. Thanks, Rohan. Appreciate it. Thanks, Justin. Thanks, Karina. Appreciate it. Thanks, everybody, for tuning in. This is CS50, pre-CS50. And good luck. Have fun. Make games. Send them to me if you make them. And I'll catch all of you later. Ta-ta.